Hello, welcome. It's been a while since I podcasted, but since it was requested, uh, I'll be doing that. Trying to check the setup. Let me get the vid to actually pass to people. It's been because it's not on the same computer I used to do it. It's actually my new one. So let's. What I'm saying is that it's gonna be a long one. What? Okay, this one's correct. Oh, perfect. Let's see. Let's make some pool. Let me just push it some. Uh, okay, I'll put. Let me just being network. Two. Okay, so that should be everyone up to date. This well, don't think I don't think anybody's here to be honest. Like, based on the fact that most people in the casting Discord are from America, and by that I mean both North America and South America. I don't know where the Europeans are, but I guess not here. I mean, yes, I'm the one. But yeah, and I tend to work in the morning where it's 11. I did have a bunch of interruptions before starting, but we're here and we can. And I'm going to explain it a bit, especially for people who are going up to our replay, because that's probably what's going to happen. Uh, yeah. So the idea here is that I've got the I've got the drawing board set up as usual. Don't hesitate to say hi if you're live. Yeah. Basically, if we remember, we are in for Castagne. We I'm currently doing well at the moment. Castagne is on its 0.6 version. Yeah, a little less. I think it's 58 probably. But yeah, it is that the Castagne 0.6 cycle is pretty much finished, which means uh, which is the part where we actually go from Godot 3 to Godot 4. But, because that would have been pretty simple. But what I actually want to do with this big update is that I want to change the Castagne core, because right now it's on Godot 3 with GD script, which is fine. I mean, it runs. There's a commercial game that's in it. But the idea is that 0.7 will be on Godot 4 with a compiled core. Because there's a few issues, but the fact is that if you're doing a physics engine and basically a full engine actually in GDScript, it's not gonna run fast. And Castagne was made from the start to be somewhat performant because you kind of need it for rollback. That's why there's a lot of constraints in CASP, which is Castagne language, and Castagne script, that allows you to make it work in parallel, for instance. Therefore, I'm gonna be rewriting it in a compiled language to actually get that performance. And on top of that, we're gonna also improve a bit on what's already there, because Castagne was made with this iterative design in mind, because there was the first version of Castagne, I think 0.0 0.3, I think that was the first prototype, which put the base of the engine in practice. At first, it didn't even have CASP. That's where Castagne script. That's where Castagne script started to. I'm messing up languages. Almost spoken Greek. Castagne script started to exist. For information, small tidbit. CASP is the file format that stands for Castagne Personnage, because I didn't think this through. But anyway, that's how all languages work. Then for 0.6, I actually, now that I got the outline, I actually implemented everything more properly in a more complete way. So that's actually a kind of a very solid version of the engine. You can make games with it. That's not an issue. But yeah, that also allowed for more experiments in design. So that way, I forgot to auto-write. That's more experiments in design, and that's why we got a lot of back and forth on some features. And now we kind of know what's good in Castagne, what it wants to be, because this was a bit rough, of course. This is a bit in the middle, because if you remember, Castagne has two main features. It's flexibility and extensibility. That's what I figure out. No, flexibility and efficiency, sorry. Extensibility is part of that flexibility. And the whole point here that, well, for me, that's the main thing. So flexibility and efficiency. If you look at what people actually value in Castagne, I mean, this is very valuable, especially when you get to that expert level. What actually people cannot work on Castagne, they don't have that same thing. They cannot work looking for ease of use, which is a secondary objective at best. So for them, it's first ease of use, then efficiency kind of works together, then flexibility if they can actually make the game in more depth. But that's what people are looking for. And the thing is that the first versions of Castagne were, I mean, it's always the case with the in development software. You want to get more. People are going to be more technical because it's still being built. You kind of need that mindset. But it's the thing is that I put that flexibility in the forefront a lot, and that's not going to change. Like that's still one of the core parts of the engine. Like because so much work and tools need to be available for several games. Therefore, you need that flexibility for all the rest of the work to be worth it. And efficiency is actually the key feature. But the thing is that in the end, it was very. I mean, I know how to use it, I've got my own way, and people find out their way, but it's really hard for them. one of the new ways I'm trying to get Castagne a bit better is that it's gonna be a bit more guided. Like it doesn't cut that flexibility, but but it does direct you a lot more heavily towards it. Because at the end of the day, it's still kind of a specialized engine. Like it's still very generic in some ways, because I'm aiming for action games in general, but not just fighting games or fighting game subgenres. But there's still a lot that's kind of decided for you. Like if you do in Castagne, your game is actually your characters are gonna be state machines, and there's gonna be a big focus on attacks and hitboxes most likely. So that's gonna be your if your game fits that. The idea is that Castagne can be a fairly good choice for it. So if you do a strategy game that doesn't need that, that just civilization or something, Castagne is not a good choice. Whereas Godot is. Therefore, it's more polarized, and I can actually use that. But so in order to do that, all of that, but without sacrificing anything, that means it's more complex on the design side, and I need more time on the programming side, and that's where this V0.7 release comes to the forefront. It's because that's where Castagne gets actually mature and won't change much, because all of these experiments they're validated. Like I know what we kind of know what works. Maybe in a few years people are like, yeah, but it can be done better other ways, most likely. But that's still gonna be very nice, and that's where Castagne actually stabilizes more, gets a better interface, and that's why there's a the big thing is on top of the core rework, which won't actually change much on the Castagne script end. Like this part's fairly stable. Maybe I'll break some things, but that's gonna be like not. It won't be that won't be mandatory. That will be me making the choice of changing features. But the the core behind that is gonna be a lot faster and more stable. That's the idea. And we're gonna have a new editor that actually works as a tools platform, because that's what because Castagne was meant to be a tools platform from the start, but of course that's always secondary to working at all. So you've seen the editor and this very big focus on efficiency. Now it's gonna get even better, but that's gonna be a long project, and that's why we're actually spending a few steps here. I'm explaining what I do, because the rest of the stream is gonna be just me programming, so that's probably not gonna be as interesting. But yeah, so this new Castagne, there's a lot of features, and a lot of them are interconnected. I'm supposing you have some familiarity with Castagne a bit, but the idea is that we always work with modules that will actually give the functionality. So when you want to change your game genre, you change the modules. By default, Castagne doesn't know about physics, so you can change between the 2D physics or 3D physics. It kind of works well. So if you, for instance, you want to make a 3D fighter, you put the 3D physics module. If you want to make a 2D fighter with sprites, you put the 2D physics and the 2D graphics module. If you want to make a 2D fighter with 3D models, 2D sprites, 3D graphics, 2D physics, 3D graphics. But yeah, that's the modules. That's what actually gives the functionality. But the core itself is the state machine and the entities and the tick flow. So actually, that's the part we're working on today. That's the engine core. The thing is, the engine core, it's not alone. So first of all, the engine core links with the modules, as we said. We're gonna be rewriting modules at some point. Mostly, we'll be rewriting the physics, especially because this one needs to be quite fast, and at the moment it ain't cutting it. This actually gives you the gameplay core. All names are subject to change, but yeah, because that's kind of where your gameplay will actually live. Like this is not what you wrote. It's still part of the default Castagne experience. It's all the spec blocks, if you're used to that. Basically, all the basic movement stuff. You can dash, you can get hit, you can die, you can this You can make attack cancels, all of that. Like the attack cancel is part of the module, but the idea that types like light attacks can always cancel into mediums as part of the global rule, that's in the gameplay core. This part's gonna be quite improved compared to the previous ones, and that's because that's the one that people are actually mostly interacting with. And they do that through the editor. The Castagne editor. So everything, I mean, I put arrows, but it kind of goes both ways. But the editor kind of works a lot with the gameplay core. This is gonna be quite a project for the editor part. Yeah, and something new is uh, the dev tools. Because, well, I mean, it's kind of getting like a big project, and it's been kind of left untested for a while, for forever. And to get actually a lot of the Castagne experience is learning Castagne, because it's the kind of software you have to put a lot of yourself into to get most benefits. Therefore, the learning curve needs to be to exist. It kind of does actually, like if you because the learning curve in Castagne is you start at the editor and then you get through the other ones bit by bit. That's what happened. Like that's confirmed in the studies I did. That's where people. But yeah, and the new editor is gonna be a lot better than the previous one. We're gonna speak about that when it comes to. But to make sure everything works and we get less bugs with all of these moving parts, we're actually putting tests in and a better distribution method, because right now it's kind of janky at times, and because we're gonna be working with a compiled code, that's gonna be a lot harder, and that's something here. The thing is that, well, engine core is still the main module, the main part, but it still gets influenced by all the other ones, especially the editor, to get better editor experience. That will put some constraints on our compiler. That's gonna be something to watch out for, and that's gonna color a lot of what we do. Then next drawing. So what's the engine core? So the thing is that Castagne's design is so big, it's hard to keep it all in my head at the same time. We kind of trying to. A lot of software architecture is putting it in parts you can actually understand, and the thing is that I didn't go all the way down, kind of freestyling some things, but that's why because at the same time, well, on one end it's more fun that way. It kind of helps more development speed. On the other one, like there's some I'm not super experienced in Rust, so don't hesitate to actually catch me and say, oh yeah, you can do that better. That would be great. Like if you can give tips to what I do. But yeah. So the engine core, there's a few parts. So what is it responsible for? It's responsible for the tick flow / engine flow. It's responsible for memory management. That's actually what makes rollback work. Without that, it won't work. And then there's also, well, the compiler, how to get from Castagne character files to something that actually runs. So of these, like they're all interconnected, of course. The idea is that the compiler takes a CAS file, and it will have to get out from here. We have to get the code to run, and it will have to get the variables, which are gonna be in our memory. Well, that's the memory, and then we have, like, in the engine itself, it will have to take that code and interact with the memory to change the variables as said by the code. And a lot of this code and what it can do comes from modules, which is why that's where it actually links to the rest of the engine. That comes in the second time. So the idea is that, well, the compiler must output for both of these, otherwise it just doesn't work. Uh, we're gonna start with the memory because that's the basic part. Like we don't need the engine tick flow yet exactly, but we need to get the variables in before we can do the code. So that's because if we that's why memory is number one. Compiler, it's then the question: do I do a compiler on the engine first? They kind of work together, but let's. I'm thinking we're gonna do the engine next. That way, something actually runs on the code, even if we have to write it manually. Of course, we won't write a full character. If it's just the core experience, the core modules, that's gonna be just some bytecode. And finally, the compiler with and then some modules. Maybe there's gonna be some interplay. It's not exactly fixed, but that gives you the idea of how we're gonna go about this. Therefore, let's start with therefore for the memory. Here's the thing is that memory is gonna be a really key part of the engine because that's where the rollback comes in. So our constraint is that we need to go back. We need to be able to go back quickly because like something like 8 frames, 10 frames, whatever, and resimulate them. That's our big performance issue. So of course we're not really thinking about performance too much here. Like we're not doing the worst implementations we can think of, but we're not gonna actually focus on performance right now. Right now we want it to work. Then we'll do some performance tests, and then we'll know if we actually improve. That means like I've got some memory schemas in mind, like ideas of how to make it fast to go back and how to, how to access previous data in O of one, limit the space, the footprint of the memory, but without any benchmark. That's kind of useless. Like we don't know how many variables we need. Like if I go through Cronjan, I think that's 500 per character. Doesn't say anything because it can actually be a bit more. So the thing is, at the moment we're gonna have an interface. So the idea is that we're gonna introduce this idea of the memory stack. This one already exists in the current Castagne. It's kinda, I mean, it was meant to happen. So the designs kinda already reflects good enough approximation. So a memory stack, what is all? It holds the variables. It holds the variables. That's the main thing, and it will, and it can be meant for several things, but it can be meant for an entity. So an entity is going to be any character that works in the stage. It can be for a player. The players have their own variables after all, or it can be the global ones. So what's an example? This one, position. Players, they don't have a lot of stuff going on, but that can be the input device. That's not really, I mean, I need to come back to this later. That can be the main entity. The main entity you control. That can be several things. And global is, well, more global stuff, of course, but that can be, for instance, the timer. So the idea is that here actually I kind of, by accident, I did stumble onto something. The input device here is that's not really part of the game state. So therefore, it's actually not going there. This is the game state only. This is the game state only because there's several parts of the memory that are gonna be more instanced. Like they need special care. Like the input device, the idea is the input device can change during the match. Like you go into pause menu, you say, well, I'm switching controller, and you're back at it. That doesn't mean you need to change it in the game state. The game state hasn't actually changed. The input did, but we still need to take care of it. That's why the input. There's some parts that are actually the input device, the 3D model, stuff like that. That's a bit more external. You know, that's we don't want to copy the whole 3D model when you do that. That wouldn't be efficient at all. Therefore, these parts at the moment that's called instance data. This exists in Castagne right now. It's not super well made. It can probably that's if Castagne has a rollback, probably the game works. But this part's actually gonna be the tricky one if you're currently on Castagne 0.6. We don't want that too much. That's so what we're gonna do here is for now we're gonna ignore it for now. Yeah, doesn't exist. But we keep it in mind, especially because maybe that's gonna be useful to store some of our constants or maybe stuff like that, you know, general data. But we will keep it in mind for another time. So, and the idea of a memory stack is you can get an address in memory, you know, with some identifier. Let's put it or you can set memory with a identifier and a value. So at the moment, in real Castagne, that identifier is a string, that's a variable name. That's not really efficient, but that's good enough because in Go script, because we are not really doing much. That's why the memory stack in GDScript is a dictionary. That's not something you want for something that goes fast, however. That's good for prototyping, not much else. I mean, dictionaries work fast enough, but for this we want the maximum performance. So, on top of that, in order to access, you know, to know what variable is what, here we're gonna have an array of variables, but to know what is what, we're gonna need a symbol table, which actually I probably need to rename. But this symbol table, that will actually give us the variable name to ID to index table correspondence. This can be a hash map, but that's because we're not gonna use it that much actually. I mean, the compiler, in theory, the compiler is already gonna work the address out for us, so that's not our main issue today. But we're keeping it in mind because that's gonna be most likely the next thing we will have to implement. The cases where the variable names are actually going to be useful is going to be for reading, like when you want to access some data, that's what we need. And what else? That's when we're going to be doing inter-entity communication. That's so that's going to come a lot later. So, and all of these memory stacks, we actually have several memory stacks that are going to go all under the memory. Like the memory is gonna have, one memory is gonna have several memory stacks. If I had to put it in a more specific way, so if we got your memory stacks, so we got entity 1, entity 2, you know, and they all point to the same symbol table. So that's for one entity. So, and maybe there's another entity, and this one comes in also with its own symbol table. So the thing is that then we got the CASP files. And the thing is that one file can define several entities. So the idea is that usually you have your main entity and you have your sub-entities. We'll go back to that later, especially because that's going to have some changes in the next one because we're kind of switching up the engine flow a bit with but one thing at a time. We don't need to keep it in mind for now. And I'm not and with how much time I'm spending on this just to explain what I'm going to actually do, you know, because that's a long part actually. That's how to know what you're doing, otherwise you're not going anywhere. And we only, instead of doing like a Castagne lecture for stuff that might not happen, let's do it here. Let's stop here. So Castagne file can have several symbol tables. And then we also got our player symbol table and our global symbol table, which are actually influenced by the modules. The modules will define what variables our players and global have, and also influences what you can do and the variables you have in your Castagne script modules. So it's here, and then we have our player 1, player 2 memory stacks, and the global memory stacks, which is going to be unique in theory. All of this is our memory, and it's also game state. The idea is that if you go back, you can go back and forth using just the game state. That's why, we got you need the symbol table will hold the rest of the data that's actually stable, and that's the second thing it will have to hold. That's why I don't think symbol table is a good name, but we get to it, is that it also most likely will need to hold the code of the states. And there are several things about how to access parts of it, but let's take it one at a time. I haven't figured out exactly how I do it. That's why your best tool is a refactor, because sometimes, it's hard to just keep everything in mind while just designing on paper. That's why we actually, let's just start, get the ball rolling, see how it can works out a bit, and adapt at the same time. Software architecture is a bit between growing a plant and building a cathedral. So you're gonna have to adapt a bit. So that's today's objective. That's gonna be that you're gonna working on the memory stack. Memory stack right now, we're gonna do some tests for it because it's actually good practice. Like, I'm not doing TDD. That's not gonna be the first time actually where I had some tests this early, except for the PhD. But the whole PhD's idea was testing performance. So of course that was an early idea. But the thing is here that will allow us to actually test what works a lot quicker. And so that's where we're actually going next. So I keep some notes in my files. Let's see. Nobody's commenting in the, nobody's in the chat. Is there? I mean, at least I don't see anyone in the chat. I don't know if that's oh, there's viewers actually. Hello everyone. I thought oh, okay, perfect timing. Okay, hello Dallas. Sorry, I didn't see you. On a new computer, I don't know exactly. Oh, okay. The window was acting funny. Okay, well, good to know. It's the first time I stream on this computer, and I see my OBS has updated. So now I have access to the chat inside of the window. I wasn't sure if it works. It worked, but the window was too small. I couldn't see you, Dallas. Okay. So let's actually start. I hope it wasn't too heavy, but here, so I'm doing this in Rust. So I've learned Rust last month, but I'm not doing C++ because I've gone through enough. I got through enough already. And so the idea here is that I've got some modules. I already got a start for Alexa for Castagne, but that's for the compiler part. Bytecode, we're gonna go back to it later. So I'm currently having it all in the engine module here by itself. We're gonna reorganize a lot in this thing. That's the early development issue. So yesterday I did some code and forgot to compile it. So we're gonna see what is actually crying out about. Unused variables and one that doesn't return what needs. So here we got our memory stack structure. It is entries, which are a part of memory entry. So to do here, that's how we know we actually we do the to do. So in memory entry, that's an enum. So if you don't know Rust too much, an enum can actually hold variables, and it can have functions defined on it, if I'm not mistaken. Therefore, it's quite flexible. In this case, we're only working with integers at the moment. We're gonna see the rest after, because let's start one by one and then add features. While our memory here has a bunch of memory stacks. So the eagle-eyed programmer might understand that we're not doing a lot of memory management at the moment. That's fine. I'm not exactly sure about the enum, how the enum will work, but let's just make an implementation that works and then benchmark it, see if it's good enough. In theory, the enum kind of works like a union, I think. I hope so. I think I looked it up, but I'm not sure. If it doesn't, we'll figure it out. Everything in its own time. Don't need to make it overly complicated right now by actually manipulating, the bytes directly without first knowing if it's gonna be useful or not. We got the symbol table, which we got the names and hash map. We got here, that's the cast command and cast var. So this is actually the state program. Okay, so this is what I was talking about. Well, cast command is actually going to be how we actually execute our code. It's also an enum, that's the bytecode. We got the external call and the internal function call. But we're also going to have some more casting specific operations and some generic ones like this addition here, which takes 3 Castagne compile, that's what cast stands for, variables, which is where we actually can find a variable. We can get a constant, that's just a memory entry, or we can get our own, and the U size here is going to be our address. So, and the program is a vector of cast commands. This is our tests. So we can have the one to test the memory value. We can have to test to initialize a memory stack. So we already have one. And then we can start, testing our functions one by one. That's how we're actually going to proceed for this thing, because making the whole setup here kind of doesn't work, because we need to have a full integration test, that will have a character from cast compile and checking if it works. That does need the compiler, that needs the engine to run, that needs the memory stack to work, and we can either do it on instinct and then figure out the bugs on the whole 3 systems at the same time, or we can use the test framework here from us to actually start testing early, even though I have to make my variables manually instead of that can work. So I do cargo build. No, it's not. Engine is private. Whatever. SRC main. Okay, we don't care. I don't care at this point. Build, it works. Test. Is it like use of indeclared type? I forgot. The compiler is nice in Rust because you get what you actually need, but maybe it's not. Maybe it's a bit distracting to have on the screen flash out for a bit. I'm actually going to make a second one on the screen to keep it here. That way I can actually check what I'm looking at. What the line actually is the use line, otherwise we doesn't compile. Okay, it compiled. Let's see what the result is. As you can see, not any test works. First of all the Lexa tests are failing because it's not done. And the engine tests are all failing because we didn't implement anything. It's kind of TBD. Actually, I'm gonna remove the Lexa right now. That way we only have it's easier to see what's happening. You have tools inside of Rust to filter the test, but I'm lazy. So we actually have to implement, let's implement the test for a bit. That's our first question here, is that do we crash the engine if we don't get the value properly, or do we not do that? At the moment, let's crash the engine. We're not at this point anymore. And anyway, you're not supposed to be able to get another one. Let's just get self entries index. Perfect. Same one. The thing is here we get the memory entry. Is it? Wait. I don't even need to get it mutable. Whatever. Let's keep it here for now. And here we actually set. So the command here is actually a small musing is that because memory entry is an enum, it's kind of annoying to check every time here if it's the correct type. I guess at the moment we can overwrite memory entry and change the type of it. It is. That could be an issue, but it won't happen in practice most likely. We could put an assert on that, but let's keep it simple for now. And ping me in 2 years when it comes back to bite me in the ass. We're gonna do index equals value. If you don't know us, here's the return type, and because I didn't put a semicolon, that's returns. So this one, here we do assert equals between the stack.get the index and the value we want to test. That's just a little helper. That way we can actually do more there. These are going to be just testing functions. I'm going to move them out of the file at some point, but right now, let's see if it works. Test. It actually works. Look at this. Like the get and set tests do work out. Therefore, our memory stack works. We can't grow it. Do we need to? That's a good question. Let's not. You just get the values you have at the start, and that's it. Therefore, now that's the. I didn't expect I need to explain again so soon. Oh, snap. But yeah, that's a design issue. It's a design issue that comes really quickly. Is that let's if you remember back at the drawing board for this, I told us we have the cast commands. So the cast commands are what actually gets executed. We got all because every state in Castagne has a script. In practice, it's several, whatever. The idea is that in the Godot 3 version, the script is an array of of function pointers, funcrefs and the like, and along with an argument list. Actually, that's very inefficient, but that's what we were working with. That's why Castagne was fairly slow. Except if you have a monster machine, but even then, if you start to get into many entities, that cranks the whole thing to a halt. That's not very fun. But Castagne was made from the start to compile to bytecode or similar, which is instead of having this, you got an array of Castagne commands that just say add these two values, add A and B, and put it into C. Then do subtraction, whatever, you know. Because a lot of what we do is actually kind of variations of that. Like, what's a move function? A move function, if you think about it, it takes like an x and a y to move, and what it actually does is that it takes the position and makes plus equals x. Not exactly whatever, but that's what's happening. So it's therefore this can be replaced by a single add instruction. You do add pos.x and that x, and you put it in pos.x. That's a simple instruction. And if I don't need to actually do a function call to get it and load it in the memory and that, That's gonna be a lot faster already. That's the point of doing it in compiled Castagne. Of course, there's still a lot going on, and I don't know exactly what instructions we'll have. What we'll have is, I mean, basic math. That's we got on the basic math operation, which is gonna be like addition, subtraction, multiplication, division. Let's also put modulo, because I like that one, and max and minimum. That's a good panel. The thing is that because we know we're not doing a processor. We're not doing a CPU from scratch, otherwise it's going to be quite slow. We can make actually some more complex instructions that are very specific to Castagne. For instance, flag raise, where we raise a flag. That's a concept that comes later, but it's basically a boolean. But yeah, we can raise a flag. That's gonna be one of the comments we can actually do. Of course, the idea is that Castagne is gonna have two special commands because there's a lot of stuff that's gonna be quite complex, and that's gonna be the actual function call, to go back to that, because sometimes you kind of need to. But we're gonna have two of them. We're gonna have the call, which will actually take a Rust function and execute it, and we're gonna have the external call, which is gonna have a Godot or whatever other engine you're working from a function. So that's what we actually have to do, and the state holds this list of commands. So this is what's actually gonna execute that command list. Okay, so the thing is that of course there's some Castagne commands they're gonna between because unfortunately we're not only editing our own entity, because an entity an entity in Castagne. So in Castagne you have your entity, that's you, but you also have a target, which is another entity. That target can also be a sub-entity, which is also your sub. If it's your sub-entity, there's several rules that allow you to work a bit better. But that means, and you can also have some functions. Some functions will actually affect the global state, kinda. Not that much actually. Not that many of them actually do, and that can be complex very quickly. Some actually will take info from the player state, and of course info goes both ways. That means, what does that mean? That means that the memory is gonna have to work overtime because, well, we want our memory to not be we want to have as little memory in our purview as possible. Ideally, each entity only needs to work with its own memory stack. But here, you can see it needs to work with other memory stacks, which is gonna be quite annoying. And the thing is that because in a Castagne, entities are able to run in parallel. Therefore, we can't even really access that memory stack, or we're not sure what we're gonna get. Therefore, there's actually something in Castagne that's more or less implemented now, is that, and you have that's the start of the frame. You got your memory thing, and then you got the memory you work on. So any entity here, entity can write to the current memory, but it can read only from the previous memory, which is it can read for the other entities only in this thing. That means that if we got previous memory and current memory, we got of course entity 1, entity 2, entity 3, and same on these previous ones. So the idea is that if I'm entity 1 here, I can write only to this, I can read from this, but I can only read from those. That's gonna be part of our design constraints for the memory, and that actually allows every one of these, because you know as you can see, they can read from all the previous ones together, but nobody is actually changing the previous one. That's static. That means they can run in parallel. They can run concurrently. We don't need the order. We want stuff to be order independent because that way there's less bugs, and we can make them, and that allows us to make the engine go faster. How we are actually going to do this is going to happen a bit later, probably using futures, but there. So the idea is that way we don't need the we only need the current memory stack as a mutable reference and the previous ones as a readable reference, which is gonna be nice actually. So let's lock in a bit here. That I actually said that because that allowed me also to think about what I'm actually going to do, because that's a nice program. But let's we might actually not need the state structure right now. Let's but this the Casva is actually what allows us to get our own thing. So if you use a own part of the enum, that's gonna be an insider. If you use target, that's gonna be another, whatever. And we're getting, so you're gonna get the memory stack. Don't want to program it right now. Let's keep it simple, and I'll refactor a bit later. Let's get that rolling. So execute cast command. So at this point here, I'm keeping it as a separate function. I don't know exactly where I'll put it, but everything in its time. So execute cast command will just do the action. So it needs a reference to the cast command. It's actually small enough. I don't think we need a reference. Oh wait, there's a closures. Let's keep it as a reference. We're gonna then, apart from that, we're gonna have our memory stack, and then as a note, I'm leaving here, it's gonna have say the read memory, which is gonna be a full memory, and yeah, that's what we do. And let's see. So let's actually create that here. So we first start by initializing our memory stack. Then we're actually creating our commands. So commands is going to be a vector of Castagne commands. Cast command add, and then we do cast var home. We're taking the 0th entry and the second entry, the 1, to put in the 2. That's what we're gonna do right now. Only 1. Of course, that's not gonna be how we write code at the end, because otherwise I don't think anyone's gonna use Castagne, even less so me. Then we test the memory value of the, wait, I forgot another step, whatever. Up, and we want it to be a memory entry integer of 2 and 3 equals 5. I think that's the correct one. I did math in school one time. Yeah, then we execute that cast command, which is right now. We got our own function before execute cask script, which takes script, which is a reference to a vector of cask command. And we got our memory stack as usual. Yeah, we're gonna need the player because we need a link to player memory stack, global memory stack, and target memory stack, which can change. That's the three links we actually have. We don't edit other entities, but yeah, that's pretty much need access to whole memory to do that anyway. So we're gonna get the whole memory. But yeah, and so we execute that cask script here, which is gonna take our commands, read only, and our memory stack as a mutable reference. And I don't forget to actually change that. I forgot I'm gonna need it. That's why you see I'm a beginner at first. That's why I'm not writing it good from the first time. So the command in script.iterator. Execute cast command. That's memory stack. Good. Let's see if it compiles. Of course it doesn't, as it's not declared as mutable. True. Forgot this. Put in the other one. Okay, so it doesn't. Oh wait, no. What? Fields. Yeah. Okay. Oh, that's. Oh yeah, that's just warnings, and we don't actually do anything. I forgot. I was thinking it should work. I didn't do any work. Why doesn't it work? Whatever. Match command. That's what we do here. So of course that's in what is interesting in us will tell us for command. So we take the add, we take A, B, and target. Now result. That's where our command will actually get executed. Therefore, first of all, let's say we can actually copy this one. Okay. Otherwise, we just references. And yeah, wait. Is this good? That's not. That's not for now. So we need helpers here because the cask var has several parts. And how can we get where do we implement it? Yeah, we're gonna implement it directly on the cask var. Get, which actually gives us back a memory entry, and we just need self. We will return match self. I think that's how it goes. Own index, and we actually need a still more memory stack, of course. Otherwise, we can't access the memory. That's how things go in this code. Stack dot get. Yeah, that's what I programmed just now. That's why I remember it. Of course. Then we get the set function, which gets self. We don't actually need to mutate the cask var. That's it's done once and it doesn't change. What we actually need to change is the memory stack, which is going to be mutable, therefore. We don't need to return anything. Match self. This is actually While that sounds like a bit like a lot like boilerplate, kinda, it actually it actually is very nice. Wait, memory. Yeah, yeah, I did program another. Yeah, I did program it here. Set and we got our value, which is a memory entry. So while that seems like I'm doing a lot of boilerplate for no reason, the idea is that once we're gonna have more control here, we're gonna be able to have constants, which and targets without actually handling each one of these at the same time. We're just gonna get one and be done with it. Maybe we're gonna have a player and global, and that way that means our additional instruction can work with whatever we want. It can work with a value from the entity or from the player or from the global or from the target, and that reading thing I told you about with here, this is gonna be done transparently. If we got a own, if we say own, we're gonna get uh, it from here, and if we say target, we're gonna get it from here. That's why we don't even need to think about it. If we want to set on a target, that's also gonna allow us to do all that boilerplate and I mean not boilerplate, all that synchronization logic that actually allows us to set a variable without setting it right now and figure it out after everybody has run, and therefore our code is stable. What's the add code? Add code is gonna be a dot get results dot set, okay, result dot set. Yeah, we get the memory stack. It's mutable. It's okay, and we do a dot get memory stack again plus big dot get memory stack. Okay, that's good enough, most likely. Add I forgot to say it's which enemy it was. I can actually output them, but I figure this is cleaner. Must wait. Oh, I forgot about that. We can't add memory entries yet. Yeah, let's. I could make it a function, but look, let's implement the trait from the Rust documentation. Let's see. Oh, let's see the other ones. First, we don't want to get the borrow. Okay, it's borrowing the value. Let's unborrow it here. We do all of this because in the end, it's gonna be easier for when we actually edit the Castagne code, because that way we know here it's actually working as expected, and therefore we don't need to do that too much. So first of all, memory entry. Let's implementing add for memory entry. Can we actually do this properly? Because, well, at this point, let's just panic when stuff doesn't go our way. That's what I do. That's the functions add. Let me open the docs in another window. Plus docs add trait add in std ops. Okay. Actually, let's just. I'm putting some bookmarks away so I can actually show show the screen. Therefore, you don't say You don't stay without anything. Not like I'm actually using it. Oh wait, I can actually oh wait. Never showed bookmarks toolbar. Perfect. That way I can actually show you what I'm looking at. So that's the add trait. That's how we can actually add some new stuff to Rust. Actually add, we have our method, right and self. Yeah. So this is the method. We're going back here. First of all, so we don't need the template file, but we need the type output equals memory entry. We're outputting a memory entry with the, yeah, I think that's how you write it. Yeah, output self. Okay, yeah, that's gonna be clearer. Read the full documentation before proceeding. So, and there we this add takes self and add takes self. It takes self. Oh, because it's a clone variable. Then let's take a reference to self here. We're gonna check later if we want to actually clone it on the. Oh, actually, I do want to clone it on the stack. That's logical. But yeah, we got self. We got the other one. The other, which is of type self too, and it returns all the self. All the way here. That's now the new part is I'm gonna wonder if I can actually check that the types are the same. That's because otherwise I'm doing like branched matches, which is not the most fun thing to do in this, but I guess let's just do it that way anyway for now. Match self. Because otherwise it's like if let, and that's actually that's the best thing. The best thing. Let b equals int other. I do think it's a code spell somewhere. Like I'm gonna have duplicated code that way. But well, if I allow addition between decimals and integers, I might have some duplicated code, but at this moment in time, that's not gonna be an issue because we're only adding stuff that's in the same part. And that's let b equals other. That means we say b equals the integer value here. Otherwise, else we panic. Well, probably could put that one earlier in the text, but one thing at a time. And therefore, here we're gonna return that one with just a new memory entry, int of a plus b. There we go. That should forgot to add the add trait std ops add. Doing old school programming. Yeah. And we can see it worked. We did implement our first Castagne instruction. That's some good progress here right now. So let's keep on that good thing, and I'll continue. Let's add some more. Let's check. What do we do first? We can create new additions and stuff. We can create the subtraction and the other methods, which I think is gonna be like the best way of to go. We can also make constants. At the moment, let's keep it at ints. That's gonna be quite nice. And after that, now that we have the memory, let's not think about the targets and stuff right now, because that's gonna. Let's start with the smaller parts first. After that, we're gonna work on the engine core and actually running a state. And so for now, it's just gonna be running scripts. Yeah, for now, let's just run scripts for now. No, not thinking about the engine phases and stuff. Then we'll do the compiler. That way we can actually make it. We can make it more agreeable to use, because I'm not doing that for everything. But we also need modules. Yeah, definitely. I'm gonna have to manage state. It's and a lot of this here, actually memory stack and all that. That's what would have been a state handle in the previous Castagne. I guess we can make it a state handle. That's I'm thinking out loud, probably not making a lot of sense. Let's add another test for constants, because constants are nice. And let's check we can't actually set to a constant. We're just gonna do this with addition, because we're smart. Let's put two constant 32 and constant 16, and we're still going to store it in the second variable. And 16 plus 32 is 48. Yeah. Yeah. And then let's do constant and so why that might sound like it kind of works. It's good to have a bit. We're not gonna test every possible combination. We're gonna test it on addition, because that's the simplest method, and that way we're making sure early that things work with this simple one, which is kind of basis of the other ones. I'm guessing the other ones can work. We're gonna test division by 0. For division by 0, the trick is that we're not actually gonna want to panic, but I'll get to that in the point. So 32 plus, what was the value here? 3. 32 plus 3, 35. And of course, set to constant. Let's get those values out of the way. Oh, we should also test for out of stack. Out of range. Let's get the we don't actually even need to test for memory value. This one should panic by itself. The simple here. What else? We're gonna want to test out of range. We're gonna get out of range too. So this test should panic. I forgot how to put that in rest. Rest test should panic. How to write this? Wow, that's the Rust book. a custom field messages. Okay, we can do that in our set. Should panic, yeah. Okay, that's that way. Of course, it should panic for the right reason, but that's first of all, it won't compile because we don't have any constant yet. Constant. And what I like about Rust, if I try to compile right now, it tells me that I didn't actually check for anything. So in this get, so okay, that way it panics if it actually tries to set it in a place it shouldn't try. Like we don't set it constant time. Therefore, expected memory entry. What is? Oh yeah. Right. I forgot about that little part. Let's looks like shit, whatever. I like being able to read. Uh, do you have other constants? Yes, I do, of course. I put a bit too many of them. No. Let's set to constant, constant variable, and constants. Okay. So, cool. Thank you. Thank you for the reminder. Okay, well, that means our tests work. I mean, we did spend time writing those tests. Is that good? Is that not? I don't know. I guess it's good. But yeah, we're having this. That's kind of slowing down development, but since we're at the start of development, it's a bit in the weeds. We're not gonna be fast because we don't have any of our development tools yet to really go fast. I know the development speed because each time we're gonna have to. You see, I'm stopping a lot and thinking a lot because on the one hand, I'm not really used to Rust yet. On the other hand, there's design questions to be answered at times. It's some of the details, and on the third hand, which we all have, I'm also streaming, and therefore I'm compelled to talk, because and therefore that does take time away. I mean, I do think faster than I talk, even though it doesn't seem that way if you hear what I'm saying. Yeah. Okay. So now we got our addition working. Let's get the other operations. The math ones. Sub div multiplication first. Not division. If we go out of bounds, it crashes. Let's keep it that way. And modulo. So what do we actually want to do here? So that's not gonna be too hard. Cast command here. Let's because it's only one instruction, we're not doing a lot here. Let's just keep it on one line and put the properly, and put the other ones in a similar way. So sub div mod max and min. Okay, so let's write here minus times divide. That's actually, we don't want to do that for divide. Why don't we don't want to do that for divide? Because this is actually like, because we're working in Castagne script, this is gonna be what's sent from Castagne. When I set to a constant, I want to panic because that's not supposed to happen. I don't know what to do, and honestly, that shouldn't have happened in the first place. The argument is wrong. Therefore, there's an issue in the data. That means it's not a problem. But here, here for division, we might get a 0 as a divider, which can happen because we're not running real time. We make mistakes. That's something we want actually to check. And we don't want to panic here because otherwise, if you do divide by 0 and the program stops, well, that's not very nice, is it? Like, remember, someone is gonna be using Castagne if there's, and that can be a nasty bug that doesn't get out until you actually got that bug. Therefore, we actually want to do an error here somewhere, which is, of course, how do you report that error? That's another thing, and that's gonna be part of the state handle maybe at the time. Well, we'll get to that one when we do a state handle. But that's what we are working on. And what we are going to keep in mind here is that we are actually gonna check for the 0 in the division. How do I keep that for? And we'll put a to do in the comments. That way we actually know what to do here. And what we're gonna do, let b equal b value equals b dot get memory stack, and we're gonna do with b. So I actually want to be able to check for equality with an integer. Yeah. So let's suppose a division can only happen with an integer. At the moment, that's going to be the best position to be in. So let's do a small match. Let's do a small match, and let's check, of course. If BV is of the type yes, memory entry int. I'm not doing much at this point. In this one case, we want to so we want to check if it's if BVV is equal to 0. But the fact I don't have the error reporting is messing my my flow up. If BVV is equal to 0, that's where we report the error, and we say, and we stop. Just stop. Return. We return. Let's do a println at the moment. A println. We're not returning actually. We put PV as a memory entry of 1. Therefore, why do I do that? That's actually, why do I want to, instead of not doing the division, I want to do that? That way, we actually have more chances for it to work properly. Because if someone is like, "Yeah, I want to divide A and B and put the result in C," and the division is wrong, okay, the code is gonna be wrong. But if the C is still equal to zero, I mean to a random value after, that can have several consequences. And I think that's also in both cases it's wrong, but it has more chances of still working. That's not standard computer science. That's custom computer science, let's say that way. That's a bit more biology inspired. But I'm doing some. I'm not doing anything like that requires proper, naming and stuff. It's just a little hack that kinda sometimes if your program's wonky, but it still kinda works. That's still a bit better than it just doesn't work. And this has a bit more chances of working. There's also a bit more chances of not being caught at the moment. But are we really in that position? I don't know. If it's not, I think that if we don't try to divide by something that's not an integer, that means the compiler didn't catch it, and therefore we panic. Whew. Okay. Therefore, this is our actual division. Now we can do the module. Oh, we can do the same thing for the modulo. What, uh, what are we but just well, let's just copy paste that code. That's close enough. We can try to not repeat ourselves by doing an or, but then we'll have to once to re-separate that just after, and that's not gonna be on the fun part. I don't like it because this is gonna get a lot more complex. Actually, let's do it the proper way. So when I talked about the stream, like when I mean people were asking for the stream. This is not the usual skill I display. This is a bit more of a, we're trying to make do. I'm trying to just check if I can still say if I can properly. Let's just check. Uh, uh, I think the thing is the Rust match macro. I think that's the one I'm actually looking for. Let's check Stack Overflow like any good programmer does. Yeah, well, match is can you do that? Uh, Comparison without pattern matching. Thank you for first. Wait, no, that's oh, yeah. Well, apparently I'm still on that one. Uh, Asset matches. That's not what I want to do, but matches here. Okay, so it's for a pattern. Well, let's try that. Let's try that. I think that's the correct one. That's the kind of stuff where if you guys know Rust, you can correct me, and I will welcome it. Because here we have we kind of need to do something like that and to check if it matches with the matches between the you know, command and yes. So because I could do a match arm, but the match arm. Actually, yeah, no, that's because I was saying he's gonna take the whole thing, but no, actually, that's what happens when you both have to learn the language, kinda, and program at the same time. Cast command. Yeah, that's what you can understand better. Cast command division. We don't care about the division actually, because we already know we're in one or the other, and we do this. Otherwise, if we're in a cast command, not audio, I don't like leaving it to change completely. Does that actually? No, actually that's because that can be error prone. If I add another operation that requires that, and this is unreachable. I think that's the proper way to do it. Okay. We'll check if whatever if we need to. Okay, so now we got that one. Okay, so now we're gonna use the min and max function. Let's not mess this up. Max. Okay, that's good. Okay, we did handle all of this. Now we're gonna test. So we're not gonna test with constants because we suppose that works. We will suppose it works as expected. But what we will do is, so we'll test check the beyond bound, check subtraction. This should be -1 because we have 2 and 3. I prefer having that instead of 1 and 2 or 0 and 1 because it's let's actually put 4 here. That's fine because that's gonna be useful. And I don't think I mean, that's not good to change the values you already have here, but I think we're good enough because we're only getting those 2 first ones and setting up the third. Actually, let me get -2 because I'm gonna test. I'm gonna test because what's negative modulo value equal to? Well, whatever. Let's not do that yet. It's not really a problem. This should equals -1. Subtraction, sorry. Multiplication. Yeah, well, let's keep it that way. No, let's put it back at 0. That's what you. When you don't have a big plan for everything, that's you get the small. Jeune, and then jeune I 0. Don't forget modulo and modulo 0. What else one is? We said the max. I would say min. Actually, now that I think of it, fellas, like we got a lot of duplicated code. Like, am I right? We have a test single command function actually. Let's do that. That way I can actually read those tests. The single command result, because you see, if I don't have a lot, I can just here. Yes, all okay, perfect, but yeah, because we only want to supply this and this. So we're gonna get we're sending it a cast command and we're sending it a result, which is gonna be a memory entry, and therefore it will do all of this for us. This is initialize the memory stack, send in one command, which is all command. We're moving it into the vector. Then we do that and we check against the results. This makes the code much nicer to read. Oh, is it? We like it. Let's do that. So with all of these ones. In this case, with the constants, we can just. That's a bit prettier. And don't forget to test that memory entry to 48. Okay. I might put some music on the stream one day, but at the moment I don't have any music. I'm just hearing some in my head in my headphones. You can put your own for this one. Maybe someday I'll put actually some music. But if you wanna wonder, I'm listening to the Exapunks OST, the Hacknet OST. And I like doing that when I'm programming. It's a nice OST. That one should panic, but we could do it like this, but need to. I hope this theme's not too boring, but you guys asked for it, so that's what I'm gonna do. If you're just hearing me talk and ramble as a background noise, that's correct too. Oh, I forgot the index. Hmm. Let's put it back that way. So. The index is here, and we are just gonna put it comma 2 at the end of every line here. That way, because that's where we actually setting that stuff. Okay. This should it shouldn't compile at the moment, but let's continue. Continue and put the correct values and everything. Can I put a to-do for the division tests? We don't have those types there, therefore we don't put it. We don't make the tests at the moment because I'm not declaring that these variables types at the moment. Some say you can. I'm saying yeah, that's. I'm saying let's do that bit by bit. So of course here that's let's get some constants because of course a constant is it's gonna be slightly more robust to change now that we tested that variables work. Constant. Wait, wrong one. Even though it's a bit more variables, it's not like we're gonna go every day here. Let's replace all stuff with constant. That way it's subtraction. Therefore, let's put it 32 minus 64. That's going to be minus 32. Yeah. Let's change it on everything. That way I don't have to. See? That's why you know we're doing really, really interesting stuff because we're not actually. That's kind of like this is not the most fun part, but that allows us to have more fun later because we know we didn't break that thing. Application. I'm not good at math, so let's do times 4, and that's gonna be 128. Division 32 divided by 4. That's gonna be 8. Division by 0. We're gonna divide by 0, and we are actually gonna get 32 here. Modulo. So that's the. Let's put the 66 divided by 32. We're gonna have 2. That's values I'm choosing a bit at random. Let's gonna divide by 0, and we're gonna get. In this case of a modulo, we actually by 1, yeah. If we're dividing by 1, we're gonna get 0 every time. Which is quite nice, because I was wondering, if you get a modulo, you're like, oh yeah, it goes between 0 and 10. And then it goes further than that. You might have an issue, like a logic issue, if you get 15 or something. But now if you get 0, that's always gonna be in range, except if your range size is 0, in which case it will crash, but that's okay. Yeah, max between the two, that's 64, and minimum between the two, that's 32. Okay, we wrote our test, we wrote our commands. What we need to write now is the trait to actually be able to do memory entry combinations. So while you might say like that's a bit wasteful to have additional memory entry directly, I'm thinking that's going to be easier on the on actually working with it. Therefore, we actually do that. We actually do some of that here, and we're gonna implement all of those traits. Memory entry. We also that's because of course we're only gonna be adding between memory entries. If you want to, that's gonna be our best bet, because for instance, we have the decimal type and the angle type that might be added, because in the end, in Castagne right now we are only using int. The thing is that when we want to do proration, for instance, decimal types could be useful. I don't know if I want to add them or not. Therefore, we're not gonna actually work on that today. We're gonna keep it as an option. Strings might also happen. Do I want to store it as a string inside of it or not? That's a good question. Booleans definitely will happen. Look at ourselves, but yeah. Let's just We're gonna do a lot of writing today, eh? Actually gonna copy that instead of rewriting it because it's almost the same code. Unfortunately, we can't really stop subtracting two memory of thread. Which other traits there are? I think there's boolean div. I'm okay with it crashing if we get to that point where we actually define my zero here. Do I want to? Do I want to panic here? Yeah, let's do that. Because any person that will actually use a memory entry here, that might be zero, is gonna be a Castagne developer, not a user. Therefore, we don't need to protect ourselves from ourselves. If something crashes there, that's the Castagne developer fault, and in this case, my fault, but I'm using a more global case because that way I can shift blame when that happens. But that means that I think I prefer crashing in this case. That's and because that way it's gonna be reported quicker, and it's not gonna change the development experience much because once it's fixed, it's fixed. It's not gonna happen again. Therefore, we're good. If it same for it if you don't have flows or something. I'm not protecting people from overflow. Don't put very high numbers. If something happens, you're gonna make fun of people who are trying to put damage of 1 million. Put some fake numbers instead. Yeah, if it's a decimal, like maybe we can check if we can try forcing one type to the other. But yeah, but I'm thinking of when we have multiple types, maybe we never have multiple types. Therefore, be good. I think no. Don't forget to use std. CMP. We're taking the min and max function, and we don't forget the operations we actually want here, and we check the what did I? Okay, so what's happening exactly here? I'm a dumbass. Okay. Okay, so that was a lot of the errors. Let's see now. Again? Didn't I just 59? Okay, forgot that one. Okay, 6 previous errors. Now it's the actual errors. Expected identifier font keyword. I was like, but didn't I write? Okay. Okay, what are the actual errors? Oh yeah, March, it's March. Also, okay. No mod in ops. So therefore, that means the modulo trait is not called like that. I was kind of just guessing. It's probably called modulo, like properly, because mod is a keyword. We can see here, and Maybe division doesn't need the modular trait. Do we have a modular trait in Rust? We'll probably have a modular trait in Rust. Of course, it would book in the operation and symbols. If you don't remember something, remember where to find it again. Pairs and symbol. Rem. Oh, for remainder. I'm good at English. Here, and we actually have another error that was further down. I put an if somewhere and I forgot. Let's just ask it again. All previous errors. Yeah, oh yeah, I forgot the or trait. I was gonna say that. Well, it's so it says here. I think I'm actually just missing that. I think that's go. Let's actually just switch up the order of the tabs. What did you say? What? Yeah, well, apparently we can't put just a whole if in front of here. Let's do that. And we have 4 previous errors. Irrefutable if else pattern. Yeah, well, it's irrefutable at the moment. It's irrefutable at the moment, therefore we can ignore that warning, but we don't remove it. Why don't we remove it? Because it's because we don't want to remove that. We don't want to remove that warning because it's gonna bite us in the ass in a couple hours if we do that. So we're just gonna live with said warning for a bit. But we have to add the partial odd and odd trait, and I don't think this one is derivable automatically. For partial odd and odd, so this is a total order, but only between certain types. I'm not sure I'm actually using the thing correctly because it is able to be ordered. But in the many cases, do I want it to panic in that case? Yeah, you get a lot of questions like that. Program and you didn't get it ready properly. Of course, what's happening here? Expected. Wait, now that's still that error here. So. What? I hope the size of the mute PV. That's what was missing. Let's see if I can actually remove that. Just this one, I'm just curious. Match command. 183. I don't know how to write code, apparently. Okay. Good. Okay. No. So we got something. So our modulo function failed. That's not good. Our modulo by 0 failed. And the min and max. Therefore, here, let's see. That's left and right. What's the left and right? Actually, you know, because that doesn't say a lot, you know, like left and right, like what am I supposed to do? Let's see. In test memory value, set equals. Okay, so this is the given value and this is the expected value. Okay. So I got 32 instead of 0. And I got, so that's for the modulo, I got 34 instead of 2. Oh, yeah. Oh. Okay, I don't think I actually implemented it properly. That's why we do tests. Otherwise, oh wait, no, I actually did. I mean, no, because it doesn't work, but that's peculiar. Is my test one or is the thing one? Let's do the modulo first. So I got 34 and 32 instead of 2 and 0. Okay. What did I send here? So the modulo, I got 66, modulo 32. I should get, so the remainder is 2. That's the proper value. Yeah. Because I'm doing 60, because yeah, the remainder between 66 divided by 32, that's twice 32, 64, remainder 2. I'm correct on that. Modulo by 0, in this case I'm modulating by 1, therefore there's never any remainder in the division by 1, integer division by 1, therefore I'm also getting the 0. These tests are correct. Let's check the max and the min, they're correct. Okay. Okay. Therefore, where's the issue? Modulo, it does the modulo properly. The division works. The modulo here, it's with the PV is equal to PV is equal to 1. Okay. So therefore I'm modulating by 1. It should work. It should work. What's the issue then? Is it in this function? Because I'm getting a modulo properly. It's in the base order. Let's printf debug like we know how to do. I think that's the syntax for this stuff with the keyboard printout. I actually, yeah, I did that already. I'm this. Oh, it panicked. Oh yeah, no, it's supposed to panic when the asset doesn't work. Oh, okay, that's the warning here. I told you like warnings can be useful, and the fact you have to ignore that one. I'm actually the test is wrong. The code is correct. The test is wrong because I actually forgot to put the correct instruction in that. And because I choose like very 32 and stuff values, that's why. Oh no, I actually did the division. I just forgot for modulo and. Oh. Come on. Okay, now everything passes. We good. Let's remove that test from here because we don't really need it. I remove the proper data because this is example code. Okay, so we got. So that's great. We did a lot of progress here in the like 2 hours because we actually working. We have a working thing. We have a working memory stack and some working Castagne instructions. That's really nice. We're not adding the complex one to it. What do you mean? Execute cast command is never used. What did I do? It's supposed to be used. They just. Yeah, I did execute cast command. What is it? What is this talking about? Memory stack. Oh yeah, because I'm doing that only in tests. Yeah, the code is never used outside of the tests. Actually, because I mean all of that, that's mostly memory. Let's take a bit and actually move some code around. That way we get our first of all our memory stack. We're gonna put all that in that memory block here. We have memory blocks here, don't we, folks? Let's without taking the cast command, did we take the symbol table? Let's see the symbol table here. Everything here. Okay. I'm gonna rename that bytecode thing. Not using it yet, so I'm not really sure. Let's go to command. Because that's where, because you can see it's already been a bit tricky to move around in this function, so yeah, that's already easier. No, but the tests now are a bit in a mess. That's why we're actually going to create a folder that we can test. We actually create a tests folder because I create a Lexa folder for the Lexa tests, but it's not part of the public API. Oh, I'm having questions that actually I shouldn't really think about. This is all public API. Therefore, let's instead of doing a lot of different test directories, let's do a single test directory. Put in a mod.rs to get our key test in there, in our helper functions. Test memory value, init dummy memory stack, test single command result. That's the kind of thing we want to be able to reuse all of the time. And then all of these tests we are gonna put into we're gonna call it memory tests. We don't have that many, so it's okay. It's okay. We have these two. And we have the ones that are supposed to fail. Cask set to constant, cask get out of range, set out of range. This is while it is cascade command test, these are actually memory tests because we actually want to see if we can use a command to act elsewhere, so it's better in this case. And this is our command, it's our mathematical tests for the commands. I'm gonna put it into commands math tests. Nice. That's where we got everything properly. That's, as you can see here, we're getting good. Let's put the mod tests here. Mod memory, mod. This is actually not for us here. This is for the command. Yeah, commands using. Min and max is used by command, but this is used by memory. Okay, let's see how it crashes now. It doesn't compile more exactly. 20 errors. Yeah, because I forgot all of the use commands. Memory test use. This one uses both. This one. Wrong. This is the one that's been using both. And here I'm using the using memory entry. I'm using the cast commands, of course. Let's, I think that's useful enough. We're gonna quickly use all that and use both engine test, memory test, command math test. Yeah. That way it accesses what's up there. In the engine we do abuse. That's the like it's stuff that's useful just so much. Like memory stack, maybe not. Memory entry definitely is something everybody's gonna use. Therefore, we put it in the scope of the engine. If you're using the engine, you're gonna use memory entry. Therefore, that way we're actually working in our module. And here we have 23 errors instead of 20, which is a progress. Yeah, because I forgot to put pub in everything that's actually public. Pubinium. And function. That's why we're actually declaring that this is meant for other people to use. Memory stack, of course, we don't. Do we handle memory stacks internally? That's not fun. Let's do. I don't really care. Is it part of the contract? We don't have a contract. We think about it later. But memory, that definitely is. Memory entry, yeah, where it is, there it is. This one's definitely public. We can't really work on Castagne without it. 9 errors now. Let's see. Use of a declare type in commands.rs. Commands.rs. Create engine memory. Commands.rs. Okay, in commands, I'm not actually using the other classes. That's why. Same in the memory, most likely. Probably want to do that. Maybe not 4 errors. Okay, now what's the actual errors? Memory stack's not. Okay, yeah, we do need to memory stack to be public. And maybe to actually, yeah, we do. And let's bring it into scope or not. We're doing engine work, therefore let's put it here into the global scope. Anyway, if you're really without too much questions. Private field. Okay, so let's put a new memory stack. This one we're not actually going to make it field public. We don't want to do that. It's actually one of the things we don't want to. Memory stack as an interface, probably we want to keep it. We want to have it public because we are going to need to do some operations for rollback, but we don't want its implementation to be part of the contract. Therefore, we're adding a new function that will return a memory stack. From entries, let's put it that way. Don't know if we have an empty one, but we will return a memory stack with the entries. And in our test, which are very nice, instead of doing that, we're gonna send a single table here into memory stack from entries and return this. Should be nice. Let's go. Oh, tests passing. I mean, I guess because there's no tests. What? Wait, what's going on actually? Engine. Do I need to put all of that on? Oh yeah, I'm done. Just that's just how it goes. Memory test. I forgot to add to tell it to use. Use the other one. Okay, and now we can see our test still pass, and we did our small refactoring in a good way. It's now 2 hours, and we got our feature and cleaned it up for better next things. We're not gonna stop right now. But I need to drink some water because I've been talking non-stop this time. I hope at least that's I hope that stream's interesting for you guys. It's and not just me not just seeing me have some issues with basic stuff probably. Not using anything. Okay. But yeah, so let's continue. We'll do the wordings as the time comes once we get something that actually works. Okay, so we got our math commands. We got our memory stack. There's several ways we can continue this. Because I'm thinking out loud through the thing. So let's get back to the drawing board. We love the drawing board here. So memory stack. Okay. Commands. Okay. We're good. Okay, so now there's several ways this can go. We can actually no, that's so we can continue in the memory direction to have a memory and maybe the state handle. Maybe the symbol table, because why not, you know? State list. Okay, so this is how we actually continue the execution. It's probably what we're gonna do actually. And because in any case, like we kind of need the state. I don't. Because otherwise, that's continuing the memory. Otherwise, it's starting the tick, the engine tick itself, which is gonna be which is gonna need state handle, and it's a refactoring of execution. And to get the tick, in any case, we do need that state handle. We will need that symbol table, state list, I'm trying to think a bit, but yeah, the engine itself. What does the engine actually have? You know, like the engine, it has this main function. That's the tick function. I mean, we're not thinking about graphics right now. Graphics is a separate process, separate whatever. So the engine, you get a tick, you put it. What do you give it? You give it memory. You give it your memory at one point in time, and it gives you a new memory. Oh, it changes the memory. What do we actually want to do here? What's the best way to do it? Do we change the memory? Or do we get a new one? I think we can change the memory, and if we need to, we'll clone it. So it's just, but it gets you memory of frame F, and it gives you the memory at frame F+1. That's what we actually need to think about here. So, of course, we have the ticker. Because it seems like I'm stopping in the middle of my talk because I'm actually thinking of several other problems, like problems that will come a lot later. Like right now, I'm thinking of training mode and save states, and then like yeah, no, that's not the moment. That's still part of it. Like okay, I'm gonna have to clone it for for the save states, but it's not something I actually need to concern myself with at the moment because I'll be more implementation dependent and not actually that different. But the engine, actually, it also got that instance data, which is useful. It is useful. And it does need that because that means that does mean my memory is not independent from the instance data. But yeah, that part's quite complex. We're gonna need to handle it at some point because the part is that if you do it linearly, that's not an issue because it's like, yeah, I create a new character, load my model and the handle for that. Okay, cool. But what happens on rollback? Well, you can say, well, now it's you can free it, but then you'll have to reallocate it just after that, which is gonna take some time. There might be operations that are not rollbackable. That's the main issue of instance data here. Probably shouldn't yet. It's something that's out of the game state. And there's two parts to it. There's the part that's static, that's like data that I actually just want to read, and that will be created at one and not change. There's the things that are going to change because if I do a model set shader, for instance, what happens when I roll back it out to how do I change the shader back? That's some questions that are gonna come up really quickly rather quickly as soon as we get to Godot itself. For information, this version of Castagne here is more feature-proof because it can be linked to other engines. I'm only gonna do Godot at this point. Like I'm not really planning on another one for now, but you never know when that can be used. Maybe someone puts in Unreal Engine, uh, whatever. The editor is separate, therefore you can still use the editor through the casting process. I don't know how exactly I'm gonna make it work, but hopefully it still works. But that means I want the editor to be separate now. But yeah, so here we only concern ourselves anyway with the game state. Everything that's graphics and stuff, that's a step further, but we do want to keep it in mind for that data, which as I said, the static and uh, the non-rollback. That's why dev can get quite complex sometimes, but yeah, okay. The engine has that. But it's not just the memory, it also gets like input here. How do I get my input? I don't have anything for input yet. Let's ignore it for the moment and refactor it when we get to it, because it's just like we're gonna refactor the out of this. Because a tick has initialization. Oh yes. There's the entity list. The entity list is part of the memory of a game state. So that's not something. It's part of something. That's data. Here. Thing is, yeah, when I execution, we're thinking of execution. So, engine tick goes through several phases, as is usual. So we got our init phase, we got our action phase, AI and input phase, putting them together. We don't need that detail for now. We have the action phase, we got the physics phase. Then we used to have the reaction phase, but with those things are going, I'm thinking of getting out. But we also have events that can happen at any point. All of these, well, not all of these, but some of these will actually need to execute a script. At the moment, we're ignoring events, we're ignoring init, we're ignoring AI and input, we're just keeping the action phase. We're also ignoring physics, we don't need it for now, we don't have physics. That's gonna be module calls. Therefore, because that means, yeah, the engine also needs, yeah, that's what that's why I started the schema and then I forgot about. That's got our config data, that's what's called config data, and therefore modules. Can't really work without that, because that's what's gonna give you our, we're gonna need some module callbacks. Yeah, okay, yeah. Okay. Because basically we're instancing the engine, what we call the Castagne engine, every time we need to have a fact. Yeah, the config data is actually something that gives you the parameters for all of that. Not the battle initialization data, which is part of the flow module, and which that tells, yeah, we got 2 characters. This we don't care about at the moment. What we care about here is that we have the modules and we have the module callbacks. But that's after. Right now, we're gonna suppose we have no modules and we don't need any. We're gonna need them soon, but we don't need any for now. What we actually want to do right now is actually to get that script and execute it. And we need to, for that, each entity has a state. And therefore we need a way to store. That's what we need to do. We need a way to store state scripts. And we need a way to we need entities. We can't go around it. We need entities with their memory stack and their state. However, that's actually that's just the memory stack. I used to have in what do you call that? In Castagne, regular Castagne, everything's in the memory. Like the state is just a variable. It's in the memory. That's correct, I guess. You can do better, but that's you get it in the memory. But here, I want to do that? I don't think I want to do that because I'm gonna need to access it quite often. And I don't want to have a few constants like that, hanging around. But again, no. Let's not think about how can I test against this state. That's not, we don't actually care for now. For this kind of functions, we can actually make some Castagne cast functions for the few people that will actually need it when we get to that. For now, we're thinking of what's the most performance, what's the best. And for the best here, we cannot just need a state ID. Therefore, we actually need our symbol table. And we're gonna find a better name right now for this because symbol state table it ain't what's gonna be. And of course, because we need to have them associated together. Because we need, what's gonna happen is that to execute a script phase, of course there's gonna be callbacks, but we're gonna have to take every one of our entities, which are memory stacks, which we get from memory, and we're actually getting the state of each one to get the state script. Therefore, we need to still have that state associated to it, that symbol table associated to it. Which we think, but yeah, but and each one will get its own state handle, I guess. How do you state handle this stuff? I guess the memory stack can keep a. Well, first of all, we're gonna have to access both the memory, the previous memory, and the memory stack, but we don't need the simple table right now because we can actually access it from the memory stack because the memory stack has no sense without the symbol table. Therefore, we do keep the symbol table together. That's correct, I guess. The symbol table contains the symbol names, state names for the state ID, and the state scripts because they're unique to each entity. So yeah, that's a sort of an entity template. I don't like the name though, because we're gonna use it for other things. A state handle, therefore, doesn't need that much. It actually needs just needs a memory stack actually. A memory stack for now and the previous memory. Therefore, I don't think we need to make a state handle structure just yet. Will it come back to bite me in the ass for a refactor? We are gonna be refactoring a lot anyway. Let's just keep it simple for now. Just memory stack. And that memory stack has access to the symbol table. Probably rambling quite a bit, but it's important for the rest. So if we got because we got the symbol table, it's got an SO variable name to ID, state name to ID. It also holds a state script because this is symbol table. This is not symbol table. I don't want to keep that name for that. I want to pick one that's kind of nice because I'm gonna be using it every time. Because it's kind of like, I mean, entity template. Entity template I don't like because this template name kind of gets used a lot in CASP itself for the user. So I don't want to add confusion there because it's not the same context. Blueprint. That's kind of here. That's kind of nice actually. Entity blueprint. It's a bit of a mouthful, as if I'm not saying entity stack every 5 seconds. Memory stack. Actually, even memory here. That's kind of a misnomer. It's actually game state. We're gonna call it game state. Or maybe not. Whatever, we can still call it memory. I think that's because that's its whole and it's not gonna do anything else, even though it's a game state. The thing is that we kinda want to keep it more oh yeah, because game state kinda has the instance data, therefore we're not using that, we're using memory. Okay. The blueprint, that's but wait, but no, it's not always an entity. It's not always an entity because it can be the player or it can be global. Wait. Oh yeah, okay. I'm mixing up. I'm mixing up concepts. That's why it was starting here, because I'm actually the symbol table here. Actually, this is only entities. Do players have states? Actually, that's an excellent question. Do players have states? Does the global world have states? Not like as a philosophical question, but can it be actually useful? You know, that's how we. So that's how we actually gonna check it. Do we want to have states? Because this in the current Castagne we don't. There's no point because we only have entities working out together. But in the new Castagne, because we in Castagne we kind of had that idea a bit in the battle init data that the world can have entities and that players can have several ones, of course, but there's also variables for both of them, and that's a hash map. We don't need a type for that. We got that, and we have the because we do want to have world entities, but what actually does the oh, uh, because the memory stack is generic, like it works for entities and for stuff. The state name, that's specifically entity focused. I don't want to have it several times. And the compiler. Now let's keep the let's keep that symbol table separated. Okay. That's how you do that's actually design stream now. It's not just dev, it's design. So variable name, let's this one, that's gonna be our symbol table. That's the actual thing it does. We don't know that. We can maybe we'll have constants here too, but that's the symbol. That's specifically variables. Specifically variables and stuff like that. But the state scripts, a state name and state scripts. That's actually, now that I think of it, that has a name too in Castagne. Oh wait, yes or no? It's a fighter script, they got it. But let's not call it fighter script because that's because we're actually peaceful here. We'll call it the state table. Yeah, there we go. State table. Okay, now that's a lot clearer. That's a lot clearer. The symbol table we don't actually need to implement right now, and this one. So our memory stack does want a symbol table. We are not gonna cut outside of it. We want that symbol table. But our entities, which are their own memory stack. So first of all, an entity is not a memory stack. That's what actually does that. An entity is a memory stack plus that state table plus the current state. And it's got a few variables on top of that, like who owns it and stuff. But with that first, we actually got through a major part of the design, which you could say I could have figured out for earlier. But that's why I'm gonna say that's the way you actually see how I'm actually working. But yeah, because we actually want to separate those concerns here. Only the entity has states. That's what it does, and otherwise that would make the engine a lot more complex to handle, because we could have entities that belong to a player we could have states for a player, and that would be weird, kinda. But that would be something else to handle, and also need to define those states as something. Therefore, if we want the world to have, entities and stuff, maybe we'll make a fake player for the world instead of having a real one. Maybe we'll do all of that. But yeah, that's gonna be what we use. Otherwise, I think that's enough to start. Because yeah, and because if we go back to this diagram, we actually, and it's what we actually want to do. We don't need that state handle just yet. I don't. Maybe we will need it. Maybe we won't. I also did the first version of Castagne without it, and then it came back to bite me. But we probably gonna need it at some point, but let's actually let's just make one. No, yes, yeah. We gonna want to make one because the state handle is gonna be there for. It's started to get already a lot of parameters because we get our memory stack, we get our entity. I mean, the entity kind of contains the memory stack through a reference, and we also get the state table. But we also have the old memory. And we probably actually want also a reference to the config data, where we definitely need a state handle. So therefore, that's what we do. We're gonna do. We're actually not gonna do the symbol table just yet, because that's more because we actually don't need it right now. Well, let's just because that's gonna be more useful once you have the compiler working. But and also we can have parts without symbols. We're gonna just use by ID. We have only 4 variables. That's okay. What we want then to do is that we want to create that memory here. That way we can actually we might not even want to do that just yet, but we want to create a state handle. We want to create our state table. That's what we're gonna do, and I'm gonna take a small break to get some new water because I'm just finishing mine right now. And I will be back with the state handle. We'll implement that state handle and state list and all of that in just a few minutes. I programmed something here that should give a pause screen and cut the microphone. That way I can talk my house. But yeah, we'll see. I'm coming back in like in a couple minutes. See you in very few. And we're back. I hope everybody got time to go to the toilet or whatever, because we're going back at it. Someone already left. See, yeah. What can we actually do? Okay. So I hope there's a few guys on replay, but yeah. Let's see. I got some water. Best drink. I got it's energized. I was not thinking like about TDD. Like I usually never do TDD. Test driven development where you write the test first and then you actually code the thing you want to code. Which for various reasons. Well, first of all, that takes some time and stuff, but I'm realizing like especially here, which I'm doing like a lot of very internal stuff, I'm doing like intermediary tests, because you don't want to code everything and then try it out, to see if it works, because that's annoying to track down bugs in. But in this case, like here, all those small tests I would have been writing anyway, I can just keep them out, you know, uh, of this thing, because I would have written a division to test if the division works anyway, in my main. But here, I don't even need to run the main. I don't need to do like a special test flow. That's really nice actually. I feel I'm getting finally in the modern times, because I've been because when I do like GPU and boomer programming, you kind of get used to bad bad moments. I get bad UX. But yeah, we're we're back at it. We have the uh, we're gonna program that state table, that state handle, and some of that tick logic at the same point, at the same time. Let's get to it then. Uh, you let's get to it. Yeah. Okay. So we got here. Yeah, let's do that again. We won't hold the bytecode. Let's do this. We don't need it as a type. What we actually need is also level of state handle. Maybe another state snapshot. State handle is a nice word anyway. That's how you are gonna access it. So everything goes through there. You're gonna write config data, write previous. Okay. Oh. And you're gonna have that entity. You're gonna have the memory stack that goes along with it. So I guess that's part of the entity. And the entity has also access to his state table. Let's put the state table. I think that's a thing. So names. Still size. Because that we're gonna handle them just by ID, which is gonna be faster. Like ID is just the type that just goes fast to get. We're gonna have several programs actually. Every state has several programs. But we don't care about that right now. That's gonna we don't actually need that immediately. We're gonna not forget it. We're gonna forget the union phase. Because also the union for events, but names. We're gonna keep one program and then we're gonna refactor when we actually get to that phase stuff, because I don't want to overly do so. We got the script plural. We're not gonna access it from the outside. But what we want to do here is a vector of what you call it again? Gas command. Yeah. Okay, so that's our state table. We actually don't need the names yet. We don't need the names yet. When we're gonna compile stuff, we're gonna get the names. That's gonna be useful for transitions. That's the part that's gonna be various levels of fun, because that's how we get the actual roots and semantics. But that's here just for later. And we get the struct entity. Or entity has got its state. It's gonna be a usize. Maybe I can create some types for that, but whatever. It's got its usize. For the state has a usize. It's got, for the script is here, it's got its state table, which is a state table, but several entities can have the same state table. Therefore, we actually want to do an RC. Well, we don't need it right now. We know we're gonna need it. Like, let's be just honest. So if you don't know Rust, RC is the reference content type, which allows several people to hold the same data. This is, of course, a bit trickier to modify because only one person can modify at a time, you know. That same logic we use for the entities, like you can't write and read from the same place from several entities. That's something that's also part of Rust in general, which is why I like Rust, because that's how I think about stuff. We can read, we can write. And in this case, we have several people that can own that state table. That's not going to be part of the entity itself. It's going to be linked to the entity. And several people are going to be able to do it. Same thing for our symbol table, when we will make the symbol table for the thing. Then, so the entity has a state, it has a state table, it has a memory stack. We just call it memory. That's I don't think it's this is also an RC, because why do we want an RC here? Because after all, the state only handle the memory stack only happens to be held by one entity. Question. I mean, yeah, of course, but I'm yeah, just in my mind, that's trouble something. But yeah, we want memory stack reference. What I'm thinking is that, you know, entities, we kind of need to save them somewhere as part of the game state. But yeah, they're part of the game state. So yeah, we just handle that. It's not an ideal entity that just works outside of the world. It's part of the game state. Therefore, we don't need to think about it too much. It got a reference to memory stack. Why does it got a reference to the memory stack? Because the memory also has a reference to the memory stack, and we want to be able to access it from both ways. Therefore, it's just not just the entity, because the memory can also handle all that memory stuff. Okay, so we got our structures. That's nice. We what do we want to do now? For the state handle, it's got an entity. That's the entity we actually use. So we're using an RC2 because we actually just want to reference to that entity. And we got, and from there we'll access the memory stack and the state table. Okay. The entity, it's a nice entity. We're gonna have some helper methods like get current script. That's always very useful. It just I use that same method from the state table. We might need to redo some of the tests. You know, I mean, some of the test setup, because it's you're gonna have more and more elements that will need to be handled. Everything in its own time. Implement state. Yeah, we'll get the new function where we actually create a state table. It's gonna be empty. So state script new. I'm not sure how performant these are, but we use each one. State tables here, get current script, therefore it's also part of this, which is get script by ID. Get and we return the script. We crash if we don't have it, because don't do that. Because we don't want people to actually check every time. We're in the critical code path. If you're messing up here, you have it's error on the programmer. We want to catch it as early as possible. We want it to crash. A user will never get that error if we program it properly. You're gonna get name string, and we're putting that on to do someday. Let's have an interface to add a state. Otherwise, we're not gonna have a lot of things, and either you do the whole script stuff, or you can do that here. But let's just add state now. We'll see after that if it's not the correct way to do that. So it's mutable self for the self here. Okay, and it's sending away a reference to a vector of yes command. Should define a type. Actually, I should define a type. Because that's something we can use. The type alias, because maybe the type will change it later. So type point equals so because we're using that, we're gonna be using that quite a lot, and that way I don't need to go over all of the stuff as soon as this changes. Yeah. So you know it's good. Okay, that's state. That's state, and we're getting a name. First of all, we get a name, but yeah. I think we get it. No, let's not put it. Let's not put the name here yet. Not sure exactly. Oh, let's just put the script. You're taking ownership of that and adding it to. Super. That's how we get stuff done. So we got our state table, and we can get the script from our state table. The entity now can get us our current script. That's a very useful helper, because we're gonna be using it quite a lot. Self.state table dot get script by ID. Self.state. So now it's just self current get current script. Okay, that's quite nice. So we got our entity. We got our state table. got some state handle somewhat. Not really, actually. We don't have a state handle. Just now, let's so it's a public structure. We gonna need that stuff to be public, not for tests actually. Tests you can do it from side, but this is all like very core engine stuff that you want to be able to access at times. At least inside of that whole thing. I don't know exactly how that works. I'm really comfortable in the Rust yet to know exactly up to where does it go, but basically if you go in and change stuff and rely on core stuff, well, you can do that, but it's on your own risk. You we do need an entity, otherwise it doesn't work. It's got the memory. It's got the previous memory. The entity as the entity stack. Yeah, put the entity here. You're gonna get it from the. It does need its reference to a memory stack, so it does need its reference to the state table. And the actual state, we don't need that right now. We're gonna go in the default 0 state, which we are gonna suppose it's the correct one. That's an excellent question. There's also a plan for tomorrow when we implement the compiler. So for now, let's just do an entity. We can handle stuff to have the state table start at 0 for an initial state, which might be the init state in the current Castagne. But yeah, and we return an entity state 0 state table memory. Okay. Public. Okay. So the state handle must have the entity we get the RC entity. If we also get the logo, but that's part of the previous memory. So new entity, return the state handle. State handles are meant to be copied quite easily. It's just references to other stuff. It allows you to have a structure that has actually all that data together to access, and some functions that allow you to actually get through to that. And therefore, we actually create a state handle. Yeah, that's just the entity. Okay, good. So I think we got our global structure. Let's put gas script to gas commands. That's where it should go. And we'll get back here. Okay. Question now is like, so now we got our structures. It's time to get the execution. Therefore, we actually modifying this part of the execute stack command. We actually want to change that to a memory stack, to the state handle. It's so it we do want always a mutable reference to the state handle. Well, I guess we can get, yeah, we do want a mutable reference to the state handle. Search for state handle because we're going to be using that quite a lot. you're gonna access. So the state handle only has private methods. When we, I mean, can access, we are be able to access through these. This allows us to actually get some slightly stuff slightly easier. Like memory, for instance, here we get through the state handle itself. That's it. Can we read it from the RC? That's a good question. We can. We definitely can. Memory. No. It's got mute, because we're gonna send a mutable reference to the memory stack. Self point entity, and I forgot the interface for RC. I think we need to. Was it the reference? That's the weak reference to avoid things. I don't care about that right now. Do I use unwrap on that one? That can be right. Use RC. As a state for stuff when you're actually more familiar with it, you can remember how to write that directly. I remember what RC is about, but I don't remember. I don't remember what. You actually use it. RC, okay, nice. Yeah, clones, don't count, don't care. I think you can just dereference it like that. I think that's what you do, actually. Entity of memory stack. Up. And here we can do that. Memory. So just. I think that's good. I think that's good. I'm not sure. Sure, but I think that's good. And in command, we get that probably. Yeah, should be good. It's a mutable memory, but we don't mutate the stack, so therefore that's what we stay with here. And execute cast scripts actually gets that same differences of state head. Here, and now we change our tests. We change our tests here. Because here it's init the memory stack, but because everything uses test single command result, we don't need that. And here we go. I'm gonna start with this. So we get our memory stack. We set up the memory stack. Then execute cast script. We already got our cast script from this, and we get the state handle. I guess that's not an issue. Therefore, yeah, we don't need a state yet, but we need that state handle to happen. So we're gonna get a state handle. Spot of it. We don't need them. We need a memory stack. Let's not. It's not some of the tests do handle with test memory value. Some of the tests handle with the state handle. We're gonna keep the state handle here, but we're actually just returning a state handle. Yeah. So we got our memory stack driven from the init the memory stack, and then we create state handle, which is state handle new, and this one requires an entity. Therefore, let entity equals entity new, which requires a reference counter to the memory stack we just made. Okay. Then we got the entity. And we actually don't need to do anything over that, so we just return it. We get it here and get test memory value is gonna be therefore. Let's return the memory stack because it only can happen under 1%. We're getting a C to the memory stack. Actually, let's just see new it here and clone it here. If it was GDScript, I would have already done that because it's used to it. It's just a bit slow. State download new and see memory stack. Because sometimes we just want to test the memory value, and in this case, do I want to go through the memory? I guess I could. I guess I could actually. It's not. That's what we don't see when you just see the updates. You don't see me go back and forth because actually I usually don't. I don't really go back and forth so much. Yeah, here we want the sh dot memory, which is gonna be our memory as part of a read. What's the L? 15. Okay. That emute memory stack. Actually, want mem. Can I coerce it that way? Can I coerce it that way? Okay, no, I can't. On the LC. Therefore, what I actually do here is, I think that's what I do. That's weird. Cannot borrow as mutable, yeah. It's not implemented, yeah, okay. Yeah, fair enough. Fair enough, but how can I access it? I don't think that was it in the docs. Because like, yeah, you can access that memory and the reference count it can. Oh, I think it's just reading. It's just reading, yeah. Oh. Yeah, so I need a box inside of that RC. Okay. So you know it's good. Actually, do I need a reference to that? Is it reference counted? Is my entity reference counted? Let's say yes. Get on with it. Okay, so it's a box of an entity. State table. State table is read-only at this point. I don't need that, but I do need a reference to the memory stack, which is mutable by several people. I might be able to, but I need to modify it, so which I can't read out the box. Okay, well, at some point you're gonna have to read the relevant stuff, I guess. So what? 13 hours. Cannot borrow as mutable. Okay, that's the RC. That's rolled a bit earlier. Let's see. Oh, we can. Yeah, I got a lot of errors that come from the rest. Private type alias. So one myself probably. No. Did it just coerce references until you got to there? What the? It's supposed to be one, not a. Oh, wait, it's a. Okay, so that's one less bug got before. Okay. But I got here a vector gas command, and instead of a. I hope I'm not doing something wrong here. If that's. Can't borrow as mutable. Okay, can't. Oh, the scripts don't change. Oh, okay, yeah, I misread the thing. So the scripts don't change that much after that. So references. What I get here. Okay, but we can't borrow the RC as mutable. But that's okay. We have other issues. Types differ in mutability. Okay, so let's go back to command. Remove some of those errors because at least we're supposed to have a memory, a mutable memory. Okay, that's already half the errors. Use of undeclared type. Okay, in the test they don't know what that is. That one. Actually, probably don't need these two otherwise. Four errors. Okay, yeah. I don't know why I keep that in. O as mutable. Okay, let's RC as mutable. And then that's this RC box entity, but it found entity. Okay. And it got here. Okay, so that's one's not too bad. We just do RC, new box, new entity. I think that's how you're supposed to do that stuff. Most expert can't. takes two arguments. But oh yeah, I forgot the state. We're gonna fix stuff one by one. The state table here is new. We do need to add some states to it, but we don't just get that one. What did I? Entity wants that. So, LC new state table. Okay, 2 errors. Now it's just that borrowing as mutable. So that's actually because we need the box type. And the box type has something to actually dereference it as mutable because it will check. Does it check at runtime? No, that's ref set. Checks at runtime. If I messed up and it's actually. Oh yeah, it's actually a ref set. Because it doesn't know. Okay. Recursive types. Okay, that's just this. I was actually wanting ref cell. It's not single ownership. Can't actually check for the borrowing rules, but we can check. Yeah. C enables multiple owners that mutable. Oh wait. Checked our compile time. Yeah, that's what we want. We want to check the mutable borrow at compile time, not ref set. We actually want box. Okay. How can we change a box? So, references. Okay. You don't care about defining your own state point. That's. Why can't I get it as mutable? Deref mutable. It has to deref mutable. It is implemented for that type, definitely. It's a box entity. It's not. It is. It says not, but it should be. It should be implemented for. Let's as yet on thinking caps on. This one's a language problem, which that means we're gonna spend 15 minutes to get to the bottom of this. On box trader, that guy's going a bit further than me. I'm already having trouble with the basics. If that was in C++, I would have just dereferenced the pointer, but that's what I'm not in C++ because otherwise I would perhaps struct. What's this? Oh yeah, trait object. Because am I missing something? Because it says it says here the interruptibility is for to understand at runtime. So that would work. But if I can avoid doing that at runtime, size, you want a large amount of data and will transfer ownership. Okay, but that I don't want to transfer ownership. No, I mean, because we have an RC. Yeah, wait, no, RC box is not something I see. I see RC refs, but because it's intermutable. Because I don't think it can actually understand that I'm using that here, so I'm gonna have to eat that performance cost. I'm gonna have to eat that performance cost for a bit. Because I don't think the box type can actually do that. If it can, we'll refactor. But because that's how we have to do it when we don't when we have unknowns, and when the language is the unknown, that's a fair assessment. Yeah, that's the value. Ah, it allows mutable balls. That's written right here. We're using boxd and we find out how to do that. Okay. And that's after I already trained a bit with us. Downcast. What is downcast? Wait, is that what I've been trying to? No, wait, that's for trait objects. That's what we saw. String, string, creative string, and if it's value, don't cast. Okay, yeah, for a type. Leak, that's for string. Does it implement the ref? Pointer was read pointer. We don't. Borrow mutable. It has it. It has borrow mute. Do I have to do borrow mute? I guess I do. I guess I do have to do that. Therefore, maybe it's easy. Maybe it's cleaner to say borrow here. Oh wait. Two previous errors. If it's a borrow item. Oh, I have to bring it in scope. What was it called again? Yesterday borrow mute. I think that's sweet though, ain't it? It's a thing. Yeah. Cannot borrow as mute. Can't borrow RC as mutable, but okay. So what's going on here is that I'm actually dereferencing the RC first and then borrowing it as a mute reference. And I think, and that's good. Let's just get here. The reference coercion's gonna be nice. Remove this. It compiled? No, it didn't compile. But of course it didn't. Expect me myself for RC box memo stack. Okay. I think like that. Cannot borrow. Ah, yeah. Wait, the RC. Oh wait. Oh, I can borrow the box as mutable, but because there's multiple owners, I can't actually do that with a box. I need a ref cell. Okay, I understand now the ideas. That was that's at least I know I had I see now that where I have my issues, so I will need to check that ball at runtime, but if we need that extra perf, we will do it. Why? Oh wait, but if we need that extra perf, we will keep that that mutable reference inside of the state handle. In the meantime, we will change the state handle to have the entity is has it. The each thing in some time. Let's first make it work, and then let's see how we need that because I don't think there's gonna be a lot that needs to change, especially because we're here. Because anyway, we're already getting a mutable reference, so therefore every cast command will already only get the mutable reference to the state handle through the state handle. So we don't need to have that much issues. It doesn't matter too much if I do something that's a bit suboptimal here for now. And I want that in the entity. I need a ref cell to my memory stack. That's where I need it. Probably don't want that either. That means oh, Jésus. Okay. I actually need that as a ref cell too, because I can modify the state. That's not good. That's part of my game state. Therefore, I also need a ref cell here. I also need a ref cell here, and that means and how do you do it? Do we? I think this one I need to say bow specifically. Well, once the compiler will tell me if I need to actually say bow, can find the scope. Okay, yeah. What else? Okay, but that's let's at least get it correct on this file. Not fill memory. Okay, that's I don't care. I don't care. Engine model S3840. There's no field memory on this state handle. Okay, yeah. So I need to do that. Oh, memory. Oh, otherwise let's see if it works. We said we're gonna see it if we can dereference it. Okay. But does it work for the small one? We got the ref cell for memory size. Okay, perfect. So it's O. And we do a mutable bore of the entity to mutable bore the memory. Why does it do? No on type. Oh, okay. I forgot the self entity. Film. Let's dereference self entity, which then perform mutably, which then get the memory, which. Okay, we're already making progress here, so it's trying to stack memory type, but we only get there. So now we dereference that one. It's not asking me for that again. It's for 2024. Okay. Yeah, there we go. That's do I have to? What's going on here exactly? Okay, so dereference that due to having a compiler driven development. That's a new one. Yeah, of course it won't work. Reference. Okay, so I borrow it mutably, and then I can't do anything with it, which is great. That is just you don't want to send blocks without to send an episode. Okay, let's already summarize on this. So many. Okay, except why does it get a memory stack here? Okay, so that's fine. Okay, first of all, let's not do that because we don't want to dereference it, but we want a reference. Okay, so if I put a borrow like this, does that work? It's can't return a reference to memory. How do I read stuff? Maybe I should have read documentation more. It does the borrow. What's going on here? It says borrow, not get. I don't get shit. Chat. That's if there's someone who knows actually, don't hesitate to tell me instead of watching me fumble in the dark. Yeah, it's important. It's not a reference. Not a reference, but you don't want to have curse types everywhere in the code base. Hopefully. Because okay, let's do that. It's not so we just borrowing stuff at the moment. Okay. I found a ref. What's the difference? What's the difference between the two? I expect a reference to a memory stack, but it said it got a ref structure. Let's ask the internet for that. So you are the that's not what I'm looking for. Ah. Okay. That's that's a struct. It's a struct and then about that I made value. Okay. Because it has the def trait. There's the borrow trait. Returns got the lifetime. Okay, that's a lifetime. And that's its type. Do we have to? That sounds weird. I think it's something wrong. It's got it. On one hand, I hope it's not private field. Yeah, private field, not method. It's everyone refs. Yeah, I know. I know, that's what I've been trying to do. Okay, Professor. I guess all my tests never had to go through that kind of stuff. A simpler code. 2 errors. Oh. Type annotations needed. Okay, so maybe let's go back to the book. Okay, so let's see how it handles that. So, we borrow mutably here. It's not, we don't transfer ownership. Borrow mutably. Okay, so what's going on? Let's focus on one error at a time. Let's try to borrow it mutably first. Okay. So right now I'm a state handler. Okay. So self dot entity. I got an RC which contains a ref cell. Let's do that one by one. If I do that, I go up. If I do that, I expected memory stack, but I found an RC of ref cell by entity. That is correct. That's what we expected. Therefore now, we actually want to borrow that thing. So it's gonna deref coerce it. Okay, it's not reference for the RC. Okay, that's not today's problem. So if we do this, we dereference expect memory stack, but we get a ref to an entity. Okay. And what happens if we do that? I dereference the value and then I get the entity itself, I think. Yeah, I get the entity itself. I can dereference the value, but so I've got what this weirdo type that I don't understand yet, which modular reference location. Yeah, I do get a reference. Why is it a cast type? Do I need to cast it or something? Is that if that was the only thing that would have been a bit sad? But yeah, if I get the memory, that should get the ARC to the memory stack. Let's borrow. Is not implemented for RC. Okay, so therefore, from that, now that we got our memory, does it reference it correctly? Am I mess with that? I'm getting a ref to memory stack. I think that's what I want to. But if I borrow it here, it says, yeah, try to borrow it, but no, that's because that's a local value. because that ref object is a local value. It's messy. Okay, I'm dereferencing properly. I got the ref to my last time. Road 5. Okay, that doesn't tell me here. Okay, so that's a lifetime parameter, and that's the ref. Okay, ref. It's absolutely file. Okay, cool. I don't want a clone. I don't want to map it. Filter map. I want to. Huh. Also, what I want here. So I can't. Okay, so the error is that I actually want to keep my reference not as a regular as reference like I got it here. I want it as a reference. Oh, okay. That's gonna be quite annoying, fellas. Let's let's turn it from, because yeah, we actually, yeah, what we want to do here is borrow the entity and get an RC to a ref cell of the memory stack. We don't even need to borrow the entity mutably. We just want to. We don't want to take the entity mutably. We always want to get that, which means we don't get two methods. We only get one. So just put it here. I think that's how you're supposed to do it. Instead of having like this, it's gonna be a self.entity.borrow and .memory. And that means we clone that memory. Okay. Okay, we don't care about that error. Oh, okay. Coerce it. Fully police. Yeah, because it can happen on two sides, let's do it like this. And here we can't move it out, but we need to clone it now. Okay, but this is an RC, so that's not an issue. That's how it works actually. Therefore, I only have one error, which is the memory stack reference in the command. We're getting through this. And now the results don't set. Okay. So getting a memory stack like this, I'm gonna get the RC to the ref cell of the memory stack. That's how. Therefore, memory stack point borrow get borrow mute set. I don't like it that much. That's a lot of the reference on the critical path. But is it actually an issue at the moment? I would I would say no, since most of our functions are not, because once we get the closure functions, that's gonna be every one of these functions we need to do. But for these things, because all of it is wrapped through the Castagne commands, these guys don't care about where the memories comes from. They are independent of the memory stack. Therefore, we can still continue there. Okay, 15 hours. I get that's progress. Value you still have to move. Okay. Okay, they can move it here and whatever. Let's get a reference. Actually, we don't even need to copy it. Ah, because RC is something you do have to clone in a specific way, but we just get. That means we also don't need to get. Yeah, we just put that here. Why the development does go quite slowly here, it's because every time I try to do something here, I have to think about where it will go and how I actually also. So because what I do here now, and probably the mistakes I'm doing right now, are gonna come in action in a couple hours. But let's make those mistakes and fix them as it goes on. That's how. Yeah. Why does it like it? Type must be known. Why? Why doesn't it like in the... Is it because this says more? Let's let's dereference the memory stack to errors. Now it's because I have a mutable reference. Okay, because it's in line 29, 36 here. That's a set function. And I need... I also got it here. Type must be known. That's annoying. It's because I need the reference. I will prepare to get the value. Do I need to clone that every time? That's definitely one of the cases where probably when I do it as unsafe later on. I do it like this. This I just get a lot of, hey, don't do that. Do I want to get several associations? It's like because I'm gonna just borrow. Let's be honest. Like borrow is the correct answer here because I'm only accessing one at a time. We don't want to clone that. How can we figure out how to make it work properly in the Rust language? It needs type annotation. It's a long ass line, and let's be quite honest. Oh, it actually gets shorter. RC, ref cell, memory stack. Okay. because we already have the, we don't, it's not like, didn't like it. Comparison operators can be chained. Let's allow it to us to tell, it's gonna tell us how to write a line properly, like it's been doing up to now. Oh, okay. Did it copy the line? Probably not. I didn't copy the line, so it's, oh, it's like, yeah, okay, because I'm calling the self, and it's RC as S. Is it sufficient? No. But I need to say it as and st bar. Oh yeah, because first of all, that's, yeah. I do it like this, it's not enough, right? Yeah. What? Because this is kind of hard to write. Is it because I'm not used to it, or is it because I'm doing something really wrong in that's really not idiomatic of Rust? Because maybe I'm thinking too much into C pointers and stuff. Because, like, I'm just grabbing my pointer and just reading the memory. But I'm going to have to jump through so many hoops. Just copy that line. Wait. Contrôle insert. Non. Shift insert. Okay, yeah. Cool, I got it, but it doesn't copy that line for whatever reason. That's my computer. Let's get it on the second screen. That's what I told you guys. I would get second screen for stuff like this. Yeah. Okay, so let's copy what they actually told us tonight. RC ref cell memory top. So it says here as a stable board. No, actually, I actually did write it properly, the way they wanted me to write it, but the, the compiler, wait, it does it twice on the. Oh wait, no, that's because I'm using the, because I used the one command card on test. Well, fellas, let's go. Well, let's see. But I think I'm gonna call it a wrap and put that in the handle it another time. Because I did write it bold, like the compiler said, but it's not here. Therefore, what I'm actually gonna do is actually clone that. It's not correct. It's gonna be performance, but that way I can flex on the performance test later and get some momentum. Because if it doesn't run, like, do we really need something if it doesn't run? Yeah, of course we don't. That's why. That's why we're gonna clone this every time and. Can I do that with only two of them? That's why, yeah. I wonder. Because because it moves variables. Now I'm actually gonna have to, let's the clone after everyone is once it moved, it moved. Okay, that's not good for performance, and we're in a critical code path, so that's really not good. But at this point, I kind of want to continue, and it's yes. I don't know if unsafe code can fix it, but let's first see if the speed is correct, and then do that. And try to avoid closure functions because I know we're gonna come back to that in a while. Yeah, come back to it very soon. Okay, so command 932. What's the method not found in RC cell? Okay, I need to dereference it first. Which I do like this. Reserves. I don't know which one to. Method net get type annotations. Again, write it. Points. What's that? Oh. Apparently it borrows mutably without any issue because it's not crying out for so for mutable reference it's not get. Oh yes, set. So I'd say there's no method called set. Yeah, of course it does. In RC, I've said am I getting the wrong one? Dereferencing from the RC. Yeah, I'm dereferencing from the RC. Wait a minute. If this was the only thing, I'm gonna do. Okay, yeah. Okay, I'm not crazy. I mean, I'm not completely crazy. Oh, or because if I can avoid cloning it, that's already a good thing. Yeah, I think that was the solution. Okay, because the reference and the RC need to be dereferenced. That's why I didn't know which one to use, because RC also implements that borrow trait. Okay, wait. Does it actually does that, or have I just thought those? Let's see with RC. Does RC as the as the baud rate. Yeah, it does have a baud rate. That's why. Okay, I understand now. That's a lot simpler. And I mean, it's still annoying. Let's be honest. It's still gonna be a bit annoying to have this double pointer. Double pointer. Jeez. No, it's not a double pointer actually. It's yeah, but now that we know that, we can go ahead and remove that clone. And we saved ourselves. I mean, we don't save ourselves, but we will save ourselves some performance here. It's kinda. I think the program rules are actually a bit more complete than what Rust can handle, so I think we're gonna still need to complete it with unsafe code at some point in the future. So unsafe is a feature of Rust where it doesn't do as many checks, and it tells you to do that for yourself. So because we know we can access that memory, maybe that's gonna be something we can use to improve the code later. However, I cannot to do that right now. Right now, I cannot just want to run. First run, then check if you need to run faster. That's the way. Oh, and I need to reference it several times. At least that's immutable balls. It's intermutability, so sure. But yeah, I guess that's a bit less. You spend a lot of time in the compiler in Rust, but it's because it catches a lot of the stuff for you. Okay. Which one did I forget? Of course. Hope it's yeah, that way it's really clear which one we're actually going to use instead of this one. Huh? Okay. What's memory 17. Wait. Okay. Which line has the number 39? No. Why do I provide the argument? Ah, okay. No. Okay. That was yeah, I did copy that line without thinking. Woo! Test okay, but the test lib doesn't work, but that's of course it doesn't work because we don't have anything going on here, and the test also need to be changed. Line 34. For execute Castagne. Test memory value as mismatch type. Okay. I'm sending a memory stack reference for the memory value, whereas I actually don't. I'm actually gonna replace it with a state handle. No, do I want to replace it with state handle? Yeah, actually, I kind of want to. I want to. That's not the end of the world. I'm gonna change the order test. Or do I get it? Or do I get it as a reference? Maybe look. Ref cell. Make it to state handle. That's gonna be the easiest way out of this dilemma. And fix the old tests. This one. That way we don't need to handle everything at all points. We just send the state handle, and the state handle will get the memory itself. And that way we access it. And let's take a reference to the state handle better. And that way we observe the quality between this, which we borrowed a stack of, and now we're gonna have errors elsewhere. But let's see if that test memory value does work. Memory test has issues, of course it does. Test must be known at this point. That was not used in the moment. Oh yeah, I forgot about the I think, do I want to make a memory set instead of the thing here? Because I tend to use that. Well, now that we have the gas. Yeah, the cask. Well, this one's actually the one that actually get that stuff. I can use that as a get. Can I? Yeah, let's do it with the cask bar. Actually, where am I? Yeah, that's how am I gonna get it? I'm actually going to get it through cask bar, which does own index dot get state handle. Does it take a state handle? It should get. It gets it through that. Yeah, no, it does need a state handle, otherwise it doesn't get it. But yeah, that's yeah, not memory. Okay. Because that's actually that's the point of the using the state handle. We're getting to the end. I think that's good. Let's and here we're gonna result.set, and instead of putting that everywhere and not knowing what to do with it, it's actually just standing in the state handle, and that's simple. It does need a reference to the state handle to get it from it. We just know the address. Actually, I have an editor I can do. Modernity. Okay. Let's cargo quick it first. Okay, well, better than expected. And now we're gonna have tests. Remember tests that we just need to fix those. It said for line 14. I say memory stack at line 14. I thought of this one. Okay. I don't need a handle here. I can just select the state handle I already got. And I already okay. Now it's the memory test. I'm testing a memory value on the stack. That's why I actually want to get the simple case for my memory test too, because these ones are a bit different. But here I'm setting. Check this out. So we get the state handle, perfect, and then we do that. The same trick we did, where we actually declare a cask var and use that to get the value. Right. Wait, no. No, we changed the test memory value. This is what we actually want to check, because otherwise that kinda we want to have it from base stuff. So we get the memory stack, we do the get 0 and the memory entry here. Because that's why we actually assert that everything works properly from that value. The rest here is a single command. We use cast commands, but this one we actually test the memory directly, which is why we don't want to do that. And we fail some tests, but that means we have a bug somewhere. That's the new one. Yeah, because I didn't set anything. That will do. That would indeed not work if you don't set the thing. So the test wasn't okay, and that means with all of that, with this test, we know that it worked, and we know that we spent way too much time on it, but it's done. Let's get some of those warnings out of the way, because I'm having trouble watching what's happening. So there's a lot of warnings that we are not using in memory tests. So because I'm using that, I'm not using that one. I think, are we using? Oh yeah, are we using that one? Not using that one. Yes, which one are we using? Whatever. Since they were not used, yeah, that's not gonna input. Command this. Because you're not really doing anything yet inside of the code itself. But now that we got us, with that we did put our state handle back in. Now next step after that, now that we got our state handle, we can access states a lot more easily. Okay. So we got our memory. It's good. Each time we use that, it's gonna be, of course, not a clone, but whatever. And we got a state table with a script. Therefore, the next step is to we run a script. We do want to run it separately, but now we want to start getting the engine together. This will allow us to actually start. Yeah, let's get the diagram, because all of these tests. Yep. Whatever. Because we got some tests on the memory stack itself. That's good. Okay, now we managed to get it with the state handle. So now we got some tests that work, that test the cast commands, but it tests it directly on as an execution, which is what we want with execution. We don't need to have, because we test individual commands, we don't want to have the full state stuff. We just want to see, hey, do I run this script? Does it do what I want? Perfect. Okay. We're gonna get some dummy objects maybe later for not accessing that, but yeah. Now the thing is that we want the engine to work. So the engine, as we said more likely, the engine's gonna have that memory. Gonna take that input. We ignore the input for now, but it's got this stick function that takes the memory of frame f to give us the memory of frame f plus 1. Not necessarily as a reference or whatever, but it actually does that. And it goes through the phases. It goes through the phases. Therefore, in this case, we just execute that. But that means they'll store or entities somewhere. And the game, that's the game state, all of it. But yeah, that means we got our execution. we now want to have the not the phases that we just but we want to have a tick function and to actually start getting an engine loop. You have to start the engine, the main loop, the game loop to start. And with that, which is why we use the state handle, because we also have our game state. Where game state we have that. So because what the tick does that the execution script doesn't is that it will, because the tick will iterate over every entity. Every entity will then, for every entity, it will have to create that state handle, get the script, and execute the script. That's how we actually start to get to a further away point in the thing. And then with that, once we have that, we have our engine main loop, and we can start actually running the engine. It never stops, which is alright, like in fighting forever. But with we can get a tick to start, and we can get the game loop to start. And once we have that, we are far enough away in the engine code to start the compiler. That's why it's a bit trickier at first, because everything relies on everything else. But once we have that, once we have the compiler and the module linking and all of that cool stuff, we can start to make some actual real tests, real modules, all of that. And this is when we actually get a Castagne that works and can actually produce all of that cool code for the fights. We're of course going to use some very simplified base Castagne scripts to do that, but hopefully that way I can actually spend a lot more time, like for instance tomorrow, on the compiler. Let's go. I drank too much water, so small toilet break. Coming back in a couple of minutes. Again, let's get this let's get this. Let's get to it then. Next step, engine. We said that just before the break. Therefore, no, it's yeah. Let me like got the playlist looping, but it's a thing. But yeah, okay. So engine. Let's get this. Let's get this on road. Engine. So structure. That's the part we like. The engine. Okay. So engine. It has, first of all, it has this very simple function, which is the tick function. This one we're gonna come up to it quite a while. Yeah, the pages, but yeah. We got tick. I'm thinking of a lot of stuff of like very small stuff, like do I get some variable from outside, because I think Castagne kind of, but whatever. We want our tick to be as simple as possible, and we don't. And the only variable that's going to be input. I mean, you could duplicate the game state, which is what the engine holds, but at this point in time, we don't really want to do that, and I'm not sure we. I mean, we kind of want to do that for rollback, maybe for state stuff, but yeah, we get to that point when we get to it, and this here, because up to now we don't have anything. Chat. I've noticed this time. Oh yeah, breaks back. Yeah, let's get. So the question is, do we get a game state? Well, the engine holds the game state. We can refactor it later and spend another hour with the ref cell if we love the ref cell here. But yeah, let's because we don't have a memory yet. We do have our memory stacks, and we do have entity with a memory stack. How do we give it to the engine? How do we create new entities inside the engine? Does the engine handle? Because before that, it was in the global stack. Yeah, there's a lot of shortcuts I took in the Godot 3 version, where I was able to hold the entities to be added, but we did have a public function, add entity. We are gonna keep that. We're gonna change the signature at some point, but at the moment, let's add an entity. And that means our engine actually has its entities, which are just a vector of entity. We don't need to reference them from anywhere. State handle does. I really don't like this, but I think that's something we can cut out at a later point. State handle doesn't. No, it's only a reference to that entity. I don't think I need a ref set to me. Do I need a ref set to the entity? And even we cannot edit that entity. But the state handle, does it do? It kind of does actually, yeah. It will need to edit the entity. But what I don't like with this way of implementing it is that I have no idea where my entity is on the heap. And that means, well, schema time. Because I don't know exactly. But because, you see here, what I want in most cases, well, that's why I'm always hesitating to do that, because the entity here, it's, like, ideally, if I have a vector of entities, my entities are next to each other. That means I access them one after another in the, I can just, read through all of that. But here, That kind of means like my entities can be everywhere on the stack. And I mean that I need to do a memory access for each one of them, which is gonna take more time. That's what I'm worried about. But of course, that's as we said many times, that can be a problem for another day. Even though with the refs, I'm kind of having problems now on top of that. But let's keep it that way. And got the entity has the memory stack, which is not held by anyone else, but who cares? It's got a state table. I need to entity, but this one I'm passing it through as I'm passing it through directly. Give me that. I'm pushing that entity. Self one entities, one push. Okay, okay. Bring it out. Forget the new. And the new will start an engine and give us. And the tick, what the tick actually does, it will for each entity we have, for each entity in or set of entities, it will create the state handle. I'm gonna put that function outside of it in a few, but yeah, let's get. We created it how? We created it with state handle, new, and infectious entity. We are cloning that one. That's good enough. Because it's just references. No. Yes. Yes, it's actually just, we're cloning the RC. Let's make it clearer. Or not. It's an RC. I don't like having. I think I'm cloning the entity each time I see it. So I'm keeping an entity RC. And then we get the state script. The state script from the entity. It won't go. Get your script. Does that work? Turbo build? Nope. We got it once again, fellas. Okay. Ferriter. It can't be. Okay. Why can't I derive? And that's okay, it's an entity. Ah, right there. That's what I forgot. Okay. That's why I didn't understand. Let's try it again. 2. Okay, there we go. Let me get it. Why do we have a get routing tonight? I'm not even getting anything attributable. What am I doing here? Yes, yeah, of course. I'm not ever using that function because it's not logical. Yep. Okay. So I almost got my tick, and since I got my state script, and I got my thing. Now the last part is to actually execute my script with execute cast script. And I say the state script and the state handle as a reference. So the mistake here is not found in the scope. Now what's the commands reimported here? Ah, yeah, sorry. Actually, this one is here. I can yeah, let's do it that way. I need a mutable state. Okay, so that's what I want. Oh, what does that mean? Does that work? Yep, it does. Test, of course, test work because we don't actually test anything yet. We got the engine though. That's why we're gonna do a test engine. Test an engine run with the I call that so. The idea here with this new test, the new test here is that we are gonna actually need to create the engine quite often. We're gonna get we get either a cask script or a casp code, which we're gonna compile and test with the script. What the value does, it's actually gonna do a setup simple case. It's not setup simple case. What it should be either init dummy memory stack or let's call this one setup. That way we have the setup type. And in the memory test, we're gonna use here. Begin with gas script, and this now we take in a script as a gas script. this one should give it back of state handle. Yeah. This gets us back an engine with everything in it, of course. And after that, we're gonna have to get our simple tests. So in this case, we're gonna actually, well, the engine new gets, and then you get the entity. So let's mute engine new, and then we do engine.add entity. This is where we actually need to get our entity. An entity, it needs an IC to the memory stack. We get that memory stack here, but the difference is that our state table this time, your state table is gonna get filled with new functions. The memory stack doesn't actually change. We can move that state table here. So entity is here. We're actually not muting up the doing any mutability on the entity. So what we do an RC new F7 new, and that state table. In theory, that's only compiling, but actually getting what are we getting for that? We are getting we're adding the cast script as a state state table. So add state, get the cast script state. Cool. Okay. So with that, we get an engine. Then we pass it one of the. Now that we can set up our engine cast script, we can check. So with that, we actually testing it the script. It's gonna be a cast script directly, and the result actually might want to get a bit of a more specific function. We're gonna get result var, and the result value. The validate value is a memory entry, where the result var is okay, so it's in the opposite sense of the other ones, but that's not matter. It's a cask var. And we're gonna do an assert equals at the end. Yeah, test memory value gets it an index, but we're gonna get directly result var get state handle is equal to result value. Yeah. One tick. We don't need one tick. We just one tick by default. That's for test. If we want to run multiple ticks, that's gonna be a specific case. Because you generally just need to run it once. So, and for this, we're actually using the setup engine we got here. We send it to the script. How did it do that? And from the engine, then we can request a state handle. It doesn't need to be mutable because it's already working on. Yeah, it does. Request state handle, but we don't know which entity we want. Actually, that's oh yeah. Right. Let's keep it that way for now. We only have one entity. Anyway, it's not done. So therefore, we're gonna get the state handle to the first entity. And that's where we'll say it's good enough. And not. So it's a problem waiting to happen, but we don't have that issue just yet. It's going to be mutable, therefore, like, you got our engine here, and now that we have the state handle, we can actually get that, but we also should do the engine tick. And then we get the state handle, know that it's a new stack, as expected. Engine tick. Probably need to go back on paper for some time of it, but yeah, let's do engine tests. And then we're gonna declare a new test function. Okay. Engine empty. Right. It doesn't actually do anything. So let's out. We're gonna do single add. Do a computation. Okay. These are gonna be the 3 engine tests. We're adding this for test memory value. Okay. Test engine empty. We are gonna get test engine gas script. And we're sending in the vector of commands we have. And then we do a gas var home. In this case 0, and it's gonna be a memory entry of 2. That's what we like here. And therefore, we're gonna It's actually just an empty vector. So let's keep it that way. Let's keep the. Let's not forget to have this just like. Let's see what's up. Engine pits. Yeah, we're not making that. That's not an issue here. It's an issue here. So 55. Asset equals here's hills and 8. What? So the reference. What's going on? Expected, but it found. Oh, okay, yeah. Let's pass it down to the line. I can find it in this scope. Yeah, okay, yeah, because it's using the use super. Oh. Yeah, okay, cool. It's working properly when there's nothing down. Let's do a new and the final one will combine all of the math commands we had up to now to get some. Yes, but yeah, a single command. We're getting it from math test because I don't like too much. 2 and it's gonna be equal to 5. Yeah. Did it work? Yeah, only the last one. And this one's gonna be a doozy because we're gonna do sub, multiply, division, modulo, minimum, maximum. Okay. Take that result back here, and this one will we're gonna cancel it all those two out. I mean, kind of canceling stuff anyway. Let's not do min and max. That's gonna. Yeah, well, just 4 then. That's already good enough. These are canceling out, but it might not. Okay, but let's get back here. So let's do 2. 1. That should be 4. 4 divided by 3 should be 1, if I'm not mistaken. Probably mistaken. It's got 0. 2 plus 3 equals 5. Okay, let's do it one by one. That way I'm sure everything got some properly. What do you mean 0? Oh, yeah. Okay, if I'm removing the 1, that should be 2. If I'm removing 3, that should be 2 again. Okay. If I'm multiplying now, that 2 times the first 2, that should be 4. Cool. Okay. I see the image. I see the mistake. Should be one here. And there we go. Okay, that means we actually managed to change several operations up to getting the last one. I should probably actually get for int instead of having I'm gonna add 4 instead. This should still be 1 if it compiles. Memory stick, memory entry. What's happening now? Oh yeah, that changes the result of the multiplication, of course. I don't like the fact that they cancel each other out. That was a mistake on my part. But at that point, 2 and 4, that's 6. Perfect. 6 minus 3 is 3. In our tables. So 3 times 2 is 6. 6 divided by 3 is 2. Okay. Okay, well, I think that's a bit more robust, but anyway, we can't really test all of that, but yeah. After all of this work, we got the engine running a single tick properly. And we read it back in a bad manner, but we do read it back. That wasn't so bad, most likely. Okay, so what can we do now? What's the next step? What's the next step of the plan? So we got our engine loop that can it engine loops, I guess. But so we got that. So the thing is that in theory, this is a phase execute, which has some missing parts. First of all, because there's several phases, and we kind of skipped over all of that, which is gonna be not nice, because we got the init phase, then we also got the action phase, we got the events, we got the AI phase, we got freeze phase. You know, very fun states to be in, and each one of these has its own script, because of course it does. But yeah, so we could already make the state table handle that a bit, and all the phases. Then we could then output on that. The phase also has, on top of the executing the correct script, it also calls the module before, module after. We don't have the modules yet, so that's not an issue. But I think that's a good next point, is just to wrap that functionality inside of the execute phase, which is going to be a private function. We don't want anybody outside of it. You go to the script phase. We have non-script phases, which actually just mean that which is the physics phase, the input phase, these kinds of stuff, which revolve around a single function instead of everything here. But we get that each point. Module here, we got module here. You get the phases, and let's write them out here because it's not like we get much more. So the phases, there's gonna be uh, action phase. That's the important one. There's the init phase. That's so init phase is only called once per entity when it initializes the first time. That's important. We got the action phase, which is the one that we will always pass through. We've got the AI phase, which may or may not happen. Who cares? We got the freeze phase. Freeze phase is just an alternative action phase for the ones that just want to get the script down if they're, because when it's for its turn and stuff, do I want to keep it that way? That's a very good question, and I have to ask again. There's the even phase, but there's several ones. Let's this is already a lot harder. So for now, let's keep it simple and with only the action phase, but we do keep the phases in mind. And we do here, we do get a phase. Wait, there we go. We don't really get current script, and we send it the phase. The phase it's got to get it to do partial egg quality clone copy debug master one, and that way we got our action phase. Just in the state table we get the script by it's the vector of state script. Get your own script, and here we get a phase which we will pass through here. And here we'll just do a match instruction. Well, what does it do? At this moment there's no other way it can happen, but in the future that means that as soon as I add another phase, it's gonna be like, give me that script. Don't forget to check the script. So that way, of course, it doesn't work because we ruled it. This is this function, not method. Subtitles. It did one, this one. Okay, never construct the next one. Okay, we got the phase thing going on, kinda, but that's already something nice because we can get. I think this is the point where we want to actually start getting the compiler involved, because from now on, like the only things that we have to do, like let's take it. Let's do because we don't have a task list, we vibe it. We do it based on the vibes every time. So got the engine, got the okay, so all we got our cast command. That's good. We got the memory stack. That's good. We got entities, kinda, but enough. We got the state handle. So there's many things we can add, and at this moment the objective is gonna be to have an entity. The entities don't talk to each other, they don't like to know each other, they just work together independently. That's and once we actually be able to read from the last memory, that's gonna be something interesting. But for now, we just that. What we're missing here so memory, good enough. Engine, we can't really do anything meaningful with it yet, which is why we actually what do we miss? Well, we miss the modules. We miss the modules. That's the last part. That's the last part we actually need, and we will need it for the compiler too, because otherwise the compiler kind of does nothing. Let's be honest. Therefore, therefore, I think the module is the correct place to go next. But at the same time, that's very dependent on implementation. Not exactly sure what we're doing. Because of course there's a compiler which is gonna take us forever. But because the idea is that modules, they actually give functions to the compiler. Because if you remember Castagne script, there's a state name like this, and then you got your branches like an F5 branch, but then you got your function like add, and it says like A, B, whatever, and if. So what's happening here is that this is part of the compiler. This is part of the compiler, these two, but this here line there, that's given by the module. I know there's an instruction that's called, but it's not a Castagne command. The module, actually, it needs to give us, for that superb command, it needs to give us a cask command, a cask command list, or exactly a cask script. It gives us a cask script of these things, all set up properly. But that means when I do that, that means all of this has already been translated for me. Which means I was going to get some funny state script, but yeah. So, therefore, up until we get this, all of this won't do anything. Like all the compiler will only give us empty command lists that we don't really care about. That's why we actually want to get some the module started. We don't need big modules, just even this add instruction is already gonna be enough. The question is, of course, the interface for that, because that's actually linked to the compiler. Because I actually need a way to to declare these functions without spending forever. Because the idea is the compiler, it's got a lot of phases and stuff, but when I get here as my module, I want to declare my function to be like, okay, yeah, register. I want to register my CASP function. What do I want to give it? I want to give it its name, which in this case is, well, simply add. Fluid. I want to give it an argument list, which in this case is gonna be like, it can take 2 or 3 arguments, but I cannot always need these, and the types are integers. So I gonna need to get those patterns here. I will need the documentation, because we can keep it outside, we can keep it inside. I don't know what's the best thing, but I keep the documentation in mind. That's not here. But I want to have a parsing function. And this parsing function is a closure. a closure that I can give it my passing arguments to, which in this, so it takes the argument list and it gives me back a Cask script. The question here is, this is a vector, but a vector of what? That's a vector of at this point we still don't know actually, because actually maybe we do know, because I was gonna say, yeah, right, you're like, yeah, this is the, because you don't want to have the text here. You want to have, what you want is actually is cask vase. It's a vector of cask vase, and you don't really care which one is it. That's, yeah, at this point, when you get to that point, you're already in the compiler. So compiler has a few phases. Compiler, there's the lexer, which is gonna get us the tokens and stuff, and actually, get our first lines here. Then we actually get to the semantics, and there we get, oh, this is the add function. That's where we actually recognize the add function as a proper function and its argument list. And then we get to the cask compiled code, and this is where we get our cask var, which cask commands in the format we want, and then we have the optimize. We have the optimized cask. Okay, so yeah, I'm seeing how stuff. Okay, so I can just figure out that any casp function will have its part of. Okay, cool. That's therefore gonna be quite that's gonna be quite easy. Let's get the modules out of the way. Let's struct module. Okay. We're ignoring the module callbacks for now. Don't really need them. But what we're gonna get in this case is going to add the function. That's gonna be a read-only list. Where are we getting it from? Excellent question. We are not getting it from anywhere. It doesn't exist yet. That's why we're gonna define it here, because it's probably part of the compiler, but let's probably compiler is the best part is for it to be. Compiler is the best place for it to be. Well, let's be honest. Okay, so let's go back, and we're getting off for component. Well, this one has a name, string. Maybe there are several names, whatever. We'll see each thing in its time. And it's got a parse function, which is gonna be a closure, which is the FN trait, I think. Does this work? vector gas function. Yeah. Hello, compiler. That we get we're sending away a copy. We're sending a copy of that function list for everybody that asks for it. We don't let people change your function list. That's not a good way to make it work. So module, we don't really care about that. However, we will declare the module core. Probably a module actually is a trait, not an object. Or it actually do a construction. Do a constructor, yeah. But it also has code. Whatever. Because here is something I'm set decorate. I don't know if that's the decorator pattern, which is not really. But I'm adding stuff to it from the outside, which is a bit weird. Not common, but for this one, it's gonna be quite alright. And I will think about it another day. It's not critical anyway. Mr. Gas function, and there we get gas function. Declare, of course, we declare the name add, and we declare the function. The argument list of which is like Castagne. And we're returning. Actually, we probably don't need to because we can infer the type, and the vector we return is cast command. Also, we can use create ng. Actually, yeah, commands are cast runtime stuff. Cast command dot add, and we're getting arg. Just the arg list. Let's get args. We can assume we get it, and it's good to panic up it now. Just function and implementation. Gonna check how to so this one thing's not gonna work first of all. Yeah. Because yeah. Self point functions. It's safe for the module, so yeah, that one. You just get an str. That's because we got it's actually a user-facing API, and str is gonna be easier to use because I can just use it. Thing. And it's not like performance isn't the issue here. So this one's going into the str as soon as I finally get one. Yeah. I don't really like how it's done here. I kind of want to keep everything in the same folder, but if everything got called mod, that's here. Name one. Mod name. It's lost. I'm gonna get those warnings out because that's gonna be enough. The core module is not sending the module back. Cool. Warnings. Modules. Self. Self. Only 4 errors remaining. It's an unsatisfied trait bound. Because we want to call the cast command. We don't have here. Okay, so let's say here, because I remember the trait foreclosures. Okay, environment with closures. Okay. Because I know I can do that. Many functions do. And with the unwrappable else, of course, I have that. But can I declare one? Okay, so that's a closure, which is that, but we can't. Because here it can. Alternative option T. I want guess function, it's here. Let's get the does that work if I do it like this? Well, I guess it does it work? It's the type for the trait, okay. It's because it's a trait, but I kind of want any. It's a trait bound, but because I think I mean that, but someone else. Figured it was always a different type. The date object reference, I had them. So I think, can I have the function pointer? What's the difference between function pointer versus closure? Yeah. That's what I want. I want a function pointer. That's basically, yeah. Yeah, no, maybe not, because I don't think that's what I want actually. But let's try it out, and if it works, it works. If it doesn't, of course it doesn't. What do you mean a cask file? Copy trait. Can't do it out. Okay. That's not. Wait, oh no, it actually did work because it knows what you've done. Yeah. Okay. Okay. Oh, well, that means we're going to go back to the engine. Of course, that's we still don't have like a whole config data that will load the modules, but that means we can still use the core module if we just link it a bit directly. So that's gonna be very nice. Let's see. Cast for send here. Okay. Yeah, kind so that moment it can be cloned or copied, but we want to clone and copy it because it's actually on the stack. It's a very light, very light. So on that on previous error, which one functions that code can be called on the compiler cast function to unsatisfied trait bounds. Okay, that means because it's also here the same way can't clone. This one we don't copy on the stack, we just clone. There we go. So core modules never use whatever, with not here, but we've got enough now because we can register our functions. Perfect, you know what? Gonna have to do many tests, but we got our function. Wait, let me just settle that one again. We got the function. We managed to get this thing here. Therefore, that was because the modules, they have other stuff to do, like the calls and that, but this is the only one we need for the compiler, because that's where it actually goes in the semantics step, and the other step here, that's where we get our functions. So because in any case, like, it's not like we're gonna have many stuff, it's just gonna get a list of CASP function. It doesn't care where it gets it from, it just wants that list. Actually, I didn't even need to implement the modules now that I think of it, because I just need that CASP function type. I'm gonna duplicate some code for it to work. That way I don't need to do the modules right now. I will just take that, say, in fact, because we're not using any of that, we're gonna just remove the modules here from now, and therefore it doesn't annoy us with the thing. Let's do a function that's just simple enough function. I can get it like so. Cast command, select all cast command. Perfect. Okay. Should compile. Doesn't. Forgot the declare function. Yes. Okay. So so we got what we need for the compiler. So the compiler has several steps. Do I want to do them today? yeah, we can still start it. It's not like I'm gonna go drink later, but it's not for now. So I've got some time. I'm still feeling a bit tired. I guess it's been 6 hours with not really any break, just thing to do. So, but still a pretty normal day. I guess being on stream kind of forces me to focus a bit more. Uh, yeah, or just we can ignore that. Let's clean up slightly what we did here. It's because it's kind of messy, like the state. We're not using anything here because like you got the state script, the phases, engine stuff. That's kind of where it needs to be. But the state handle, it's here too. The entity, we have the entity. We have the state table. I guess that well, we can keep it that way for now. Let's delete these empty files. Okay, we got the tests running well. We got the lex. So let's get the quick topography of the compiler. We'll have a whiteboard here. So compiler, what does the compiler do? The compiler has several roles to fulfill all at once. That's why it's gonna be very complicated. But we're gonna to do that tomorrow. So if I do a stream tomorrow, but the compiler it needs to convert the CASP file into CASC code, which is nice, and it should be optimized. So okay, that's one role. The other role it has on top of that is that it should take a CASP file and give us something for the editor to work with. That way you can actually read what's going on, you can understand what's going on. That's very nice, and that will allow us, compared to the previous version of Castagne, well, it kind of does. That's why the Castagne parser, when it became so complicated, it's because it actually needed to also get some extra data for the editor. That is what will power a lot of the editor tools. And we can keep some of them for later, but that we do need to keep in mind that we have the editor to have here. The last one, that's the one that's gonna be the trickiest, I guess. Do we need to? I'm thinking while I'm speaking, but we might need to actually be able to go back those steps. Why would we need to be able to go back those steps? Because we want the editor to be able to generate some CASP. So there is a structure. We do need a structure that keeps that in mind. Because the idea is that we're gonna have, if you remember the custom editor in Castagne, that means it was basically we could declare a variable. Like I would declare, well, actually it was constants only, but I could define whatever cool variable I want as an int. I put it to 5, and then Castagne could actually read that, the editor, and it would make a cool interface where I had my variable, and here it was written. And if I change it here to put 200, for instance, then the code will change again to 200. So this might need to be some going back through some steps. I'm not sure if that's where we want to implement it or if it's something else, because we only change the parameters, so I guess we kind of need that interpretation, but it doesn't really matter too much right now, because so we got our 4 compiler steps. four states, five states. So we get, first of all, we have our CASP file. That's the input. That's our input. We don't really care what's going on with it. You get it from your disk, or whatever, or the editor, or whatnot. Then we're getting to a part which it's tokenized. So it's a way, basically, we already read through it once, and we're like, okay, that's a state name, that's a function name, that's an argument. Instead of having, instead let's take a code. So this is add A5 B, and there we actually get, we know this is a word. We get the word, we get the opening brace, we get an argument, we get an argument, we get an argument. That way it knows what's it actually reading. Maybe not exactly like that. This is the lexer or scanner or whatever. But yeah, then, so that's the first step. That's just reading the file. Then we get to an intermediary representation, which we, representation, which is basically its semantics. It means it's a function that's just add. That's an add function, and we know which one it is. We have its data, and it's in the state. We know what state it's in. And we have some data on the state. This is what the editor wants. This is the thing that the editor can kind of read. I mean, that's maybe not, but that's at least actually that's what the editor can read. It wants the list of the functions. Then we got the raw cask. I haven't got a name for that one. We're gonna find the name together. Then we got the raw cache. That's actually what we could do to compile. It's a small step, but the raw cache plus some metadata, it's kind of part of this whole intermediary representation in sorts, because we actually want to get we want to also give that to the editor. That means that at this point, every function, or add function, has a script. In this step, that script can be traced back to the add. That's what we want, because that way we can trace the execution live in the Castagne editor later. Therefore, and then we got the optimized cask code. So that's also part of the compiler. Optimizer, I don't know. But the idea here is that if it can do some optimizations like dead branches, function calls, all of that good stuff we love to do, it can have it here. Because at this point, what it gets as an input is that raw cask without the metadata. It just gets the cask and outputs better cask. That's where we get our constants. That's where we get our constants field. That's where we get our everything else. So that's our steps. For this compiler, at this point, we're not implementing any optimization as of now. That's gonna come later. We just want to get from that cask file to the raw cask. This is once we've done the profiler, all of that good stuff, then we'll talk about optimizing it. Maybe at most we have the inliner. I mean, we will inline the states because that's something we want to do. We don't want to have dynamic dispatch inside of Castagne script. It's a very simple language. That's why we're actually going to use a lot of that as an example. Thing. And part of it is that our Alexa is gonna be quite simple because a Castagne script is simple. And one of the because we don't want to have like a complex grammar and expand the alphabet, all of that. I think it's called recursive descent or something. I saw it in class one time. Very cool way to make compilers. But here we actually do something very simple because we go through each line one by one, and each line can only have one command. What's a Castagne line? There's a line can be one thing. It can be a state name. That's one type of line. That's the only thing it has on it. It can have another one, which is it can be a function with an argument. Okay, that's nice. It can be a comment. Cool. We love comments. It can be a documentation command, which goes a bit further and allows you to pass through some additional information to the Castagne script itself. We can have an empty line. We don't care about that one. It's empty. What else can we have? We can have a branch. That's it's one branch. And we can have a keyword like else and if. I think that's the only ones we have actually in Castagne. So, of course, there's questions like comments at the end of line. Can we add that? Maybe that's in the previous Castagne we can't. Maybe we'll add it in this one. Another question is doc comments we can't actually. We won't be able to. That's good behavior. Can we negate branches? Maybe in the future. That's one thing we can do. Like maybe do an else if. But yeah, that's for a second part of it, and therefore at this point we actually we can't do all of that with just one character of look ahead, because in any case we want to be able to escape the double point, escape the end. We want to be able to recognize a doc comment, but that's about it. And I think the Lex can just does. I don't think that was for the Lex part, but that means it doesn't need to go super far. We will. Maybe it's not the correct term. Whatever. It kinda gets the job done. Because at this point we don't know functions. We just say, oh, okay, that's a function line. Okay, that's a comment. That's what we want to. We want to actually sort these out. And with those symbols, keep the line, keep whatever. So we got actual feedback on our comment. But yeah, so that means that the state name actually goes as a state name token. And this goes as a function token or whatever, function name token. That way we actually know, oh yeah, there's a variable declaration. Var name int equals value. What does this do? Well, this has a lot of stuff that was meant for actual better editors, so we'll get to it in a few. But at this moment, let's ignore variables. But we don't need to implement all of it at the same time, you know. So we can ignore variables. I think comments, that's nice to have, because we actually want that. But this is mandatory. Without that, we don't have our states, and that's bad. Then we want the functions. Otherwise, we don't do anything. We're gonna want the branches. That's what we actually want to have here. So that's what we're gonna start to do, and see where up to where we go. And that's probably going to be okay. So I've already started, as you can see, like I built the branch with the branch types. I'm supposing you're kind of familiar with Castagne script at this point, but yeah, well, if you don't have that. So, the lex script, it has this lex line function. That's where we actually will test it. Instead of having it directly, we're just gonna use our lex line, and we have the lex tests, because this is not always something public. So we got the lex line test. It's what is that to do? Don't remember. I'm trying to remember. Lex test and the lex here, and do we? What's the trick? I do have the compiler. What did it? Variable test. Why don't they appear? Oh, they appear now, because I'm actually using that, and you get some of these. Oh yeah, we're not gonna implement every type of branch immediately. Oh, actually, yeah. What? How many branches we have? So, actually, yeah, that's a good question. So we have the frame branch. We have the variable branch. We always use one character to so f branch, v branch. We got the flag branch. We got the input branch. We got the random branch. It's actually not. Oh wait, I'm not. Frame branch, variable branch, flag branch, input branch, random branch. Otherwise, we don't know how to make it work. But most of those branches we don't really need immediately. To find that again. Yeah, that's good. That's good. Actually, it wasn't saved. Okay, I guess it's just the extra test still. But yeah, we got sequential branch. The sequential branch is quite important, but it's actually just a frame branch in disguise. But yeah, so the ones we're gonna want to implement is actually the variable branch, the variable branch to get done. The frame, the frame and variable are the ones we want to get as soon as possible. Actually, just variables, just a great way to start. So therefore, let's put all of these branch tests to the. Let's hide them. We don't need them right now. We'll put them. We'll put them in when we actually need some frames. But at the moment, we don't know what a frame is. Our engine runs without that idea of states and frames in states. It doesn't take care of time. Therefore, we're just gonna use some basic function. Can recognize a command line. Can recognize a function call. I have the lex line test. This will it works exact same way as what we did before. We need to find a document. Forget test. Do of course some at this point we just get our thing. So we got the function call. We'll get keyword else, keyword and if. Call of name print name. What's the which manga says spam? Am I getting stream sniped? Yeah, that's a good point. Let's put it on no messages so I don't get doxed in it later. I actually don't know exactly what should here. At this point, I'm adding. How are you going to have separators and stuff? So, because if an argument can get all the tokens, that's the question. Because how am I going to pass all of this, especially the branches and all the things here? Let's for now let's put that at the to-do stage and work through this one at a time. Brain starting to not work as well as before. So gotta go test. Okay. Where's the mismatch? There. Not yet implemented, not yet implemented. Okay. Yeah, we get that. Everything is like this. So we got the command line dot command function call doesn't work. And we don't fix the state name. So the result type, like we want to throwing some errors, but I don't know exactly where. Because we're gonna do that in 2 steps. Alright. So as we said, like because here the Lex is kinda doing like also some semantics. Like because it's that way it's gonna be simpler for the pass a bit later, you know, if we know the functions and the arguments and all that, it's gonna be simpler for intermediate language to get through it. Because we also have like expressions in arguments. Because that's gonna be a big one if we can get that. And probably people are gonna ask for it at some point. And I don't want to make Castagne script too complicated, but at the same time, that's gonna be quite a feature. I mean, when you the add function's nice and all, but you know, maybe instead of doing add then thing and thing, maybe we want, maybe we don't want. At this point, we're ignoring this, and this. That's we don't care. We just do basic functionality. But the idea here is how much do I want? That's a decent question. Like how much do I want it for before the intermediate representation? So for intermediate representation, it says okay, so there's a state and it has these functions. It has this branch that has this function on one end and this function on the other. And then after the branch, we go back to the function. That's the kind of stuff that intermediate representation wants. So, and this is useful because we also know what's in there. We know that. Okay. This one has the semantics checked because, but here we say every line we got our token list, which is, oh, that's a state. That's the name of the state. But yeah, that's still a list of tokens, and then we'll go through each token and add the functions and stuff, which are func call, and then we add like end command or whatever, func call, and then we have argument. So this is gonna be passed just later. At this moment, we just check if it's grammatically correct, and then we check if it makes sense. We have a tree. We got a branch declaration, but because branch can have ranges and stuff, like if the range is correct, if the arguments are correct, that's gonna be this part here. And the thing is here we already simplified that work, but because we need to get from that part, well, func call argument, yeah, we need, because at this point we only have the lines and the chars, separate chars. So that way we will transform this into a word. We don't know what semantics the word has, but we know the word. We know it has. We have the open parenthesis as a token. We have another word, and then we have another thing here. So this is just the first step. That's just we scan this. Then we make sense of it. Because yeah, conception's a bit messy here. Because this is all of the scanner. this is the well, this allows us to get already a good idea of what we actually want to do. We can have several internet representations. It can is an internet representation of sorts, but there's several. This one's the one we don't we because this one we just get it quickly and then we don't care about it. And because we are in a very cool spot with the each line does its own thing, we can just get directly to this one from a simple line, and I think that's the best course of action. But the idea is that way that's why we got our Lex line token, which is a word, an argument separator, function call open, function call close, comment start, dot comment start. This will actually get. This is the first type we do, which is get those tokens out. So let the vector new this, and then we do for C in line. Well, first of all, line dot trim dot chars. Column has two. So we want the current char. We're gonna match it. And we'll pick or consume more characters. Like current word. We're gonna match C. So this is our escape character, which I have to escape. This is gonna be the fun part, which we won't take for now. For now, we don't escape characters. Okay, perfect. This is where we want to actually split between the two. But then there's some characters we already have, which is this one, column. And in this case, we want to stop the current word and get a new character out. We want to do that for history. And that's a lot of duplicated code, actually, yeah. What do we want to? Because we have the empty space, that's something. Trying to make sense of the thing depending on the next character, because we want to add it to the current word. Like I know what I want to do, but it's just how can we write it properly? Because this we want to get back one of these next line tokens for the column. But we also want to stop the current word, because that's what we do. We need to stop the word. There's two cases actually. There's two cases. It's a word continuation where we add the character to the word. It's a separator, in which case we ignore it but cut the word. We stop the word if needed. And then we got a last one, which is it's a special character. In which case we cut the word and then we add the word, but then we have the final one. How would you call that? And add the token. So in this case, there's no token. In this case, there's one token. Word. In this case, there's two tokens. Word and character. Because the thing is that, but the token word not should be added only if not empty. Well, and I want to actually check if it's empty or not. That's an issue, because ideally, like, I want to let the new token to be match C, and just return a new token if there is some. Otherwise, return none. So in this case, because that's actually kind of what we want to do. But the thing is that if it's a separator, that's where we actually want to word token. Let's do it like this for now, and but I will add. Because any of those special characters acts as separator of sorts, but we don't want the white space necessarily. This is. And instead of calling it, let's call them what they are. They are comma. At this point, we don't have the semantics. We just already just get the words out. That way, we know we just don't need to do all of that. We do it once, then we just iterate over it. That's the tricky part, and that's, and in any other case, we take the current word and we push C. which is nice. Now, then this part here, I don't, because we can make a word token, like an empty word token, but that's not good. Oh, so it's very. Because add word, let's put it to false. By default, we don't need to put that word yet. And but if we here we set it to true, that way it's here, and we do if. Then we do either we said we added a word. If let sum equals new token, add word equals true. With this, that means that if we add if we have matched something, we will treat it as a separator, but here we don't have any separator, we do treat it still. That way we don't need to add anything to the enum, and it still does that. And so we can do, if we add the word, if you want to add the word, and the current word isn't empty, now we take the line tokens, current word dot trim, current word isn't empty, and we can trim because we already matched the separator. That's not an issue. Line tokens dot push, and we create a new lex line token type word. We send it current word flow. Current word is should also clear. I don't know if that's a function. The compiler will try if it's not. And then if let sum token new token equals new token, that means now we actually add that token we said we would add. And then we do if current word is empty, because if we have to at the end of the function, because we trimmed it, we don't have any line return or anything. Therefore, we just push back that token. We just push that Lexine token. There we go. That's already, at this point, this can't fail. Either you get an empty line or not. Let's just take it out of this function to make it. That's gonna make it a lot easier. Let's put line tokens here. Also, let line tokens equals what do we call it? Lex script. Yeah. Lex script. Lex line tokens. Line. Okay, this should be good. Let's see if it compiles. The answer is no, of course, but we. Okay, so I forgot one of the Lexine token. I forgot several stuff. Okay. So 69. This one's out here. This is not 75. This is closed. Oh, it didn't. That's weird. Not a pattern. Thank you. I. Okay. Alter yourself. Add word. Yeah, we actually need to return none in these two cases. Guys, I'm telling you, by the way, that means that because we handle UTF-8 script, no, hey Pixen, so it's because we handle UTF script, that means that you can use smileys as identifier. The first one to use a smiley as an identifier in Castagne code gets banned from the Discord immediately, but you can do that. Keep it to yourself. Okay, so next slide. Okay, now that we got our tokens and we suppose it works, we're not gonna test it directly because that's kind of overkill. We're just gonna test if we actually read the lines properly like we want to, and if we don't, then we'll get to that. But here, I'm gonna put that comment with the other one here. That way, yeah. We're gonna clean some code later. But now let's analyze the line. And so go back to the whiteboard. Okay, so now we are in this configuration. There's nothing one here anymore. Didn't see the comments because I had the dot on the other screen. So now we got the word, we got the parentheses. We can actually start matching. We can start matching these fellows here. It's gonna be a function name, it's gonna be a variable name. It's okay. We don't really need to know at this point. We just need to check if we got the correct line. So let's start to get the state name, which is column, and word. So we want to see if it matches that pattern. If there's anything after it in this line, that's not good. How can I do that in a good way? That's the question now. That's a question. How can we? Because if we're honest, fellas, that's a slice function. We want to match a pattern. We don't care which one is it inside, but if because it's only gonna be a 3-line stuff. I guess that's because we want to get an error if it doesn't. Oh man, that's starting to be a bit late for me to get into these kinds of questions because that's I mean we kind of want like kind of like a regular expression or something, but like it's not the coolest one because at this point we only have very simple parts, which is we got our lines can be one of these types we implied earlier, and we're gonna recognize the few of them. So state name, column, word, column. Add word, open parentheses, bunch of arguments, separate arguments, and branch. Let's do that for later. At the moment, everything happens the same way. It's gonna be fine. So this is column, word, column. Okay, this is actually as a regex. This will be a word, open parentheses, and then you might get either you get one argument or nothing at all, and then you can get several times that. I don't remember what's the regex thing for that, and then it's function close, and you get only that. You need to. So in practice, that's. Are we getting back to the alphabet stuff? We're gonna match. We're gonna match once again. We're gonna match once again for a subline. Subline here. So let's match. First of all, let's match that that first line talk. Right. First of all, we get tokens, which is gonna be new. At the moment, we're not handling mistakes. We're only on OK tokens. But then we'll match on each one of these. Because if the first one, first of all, if it's empty, let's say if line tokens is empty, let's return early with an empty vector. If for some reason we don't have anything, well, that would have been something we actually checked here, but whatever. We are already not getting anything here, so we're already getting that empty vector. So line tokens there. Return OK. Now the tokens are here. We're getting, because if we watch a word, that's actually a function called can we just do that? No, wait, that word can be a branch. That word can be a branch, right. But that first token, those allow us to differentiate a lot of the functions. Actually, everything that's complicated is tends to be something once we don't have that simple stuff. Because once the comment hits, that's just words after that. Once the comment hits, we can just go into, yeah, that's a comment, and continue. When we get, oh, that's a documentation comment, we can go that way. Yeah. Let's match on the first token first, and then we check the rest. Because, yeah. Do we even get only one token per line or several? We can get several because we might have more comments at the end of the line. Let's not already do that. Let's just get this thing done. So first token, it's line token 0. Okay. Match first token. That first token, let's if it's a lex line token of type comment, we know how to handle this. That's just a full comment. That's the rest of it should be words. Wait, no. Start. Actually, I should just Being, because I don't want, because I kind of want to munch the tokens as I go through them. I kind of want to collect every other token after that. Yeah, as far as not really going through that very well. What I actually want here is a sub. Does that work? How bad is it? On the token type, yeah, I've got a type token. Token. What's the token types at the moment? I'll get to that later. So that's a token type. Our previous error was the error. Cannot be built for a next line token. That's very true. That's very true. We can't build that from there. Uh, can't build string from. Oh yeah, but when we get to that common token, we stop reading words. Let's go back to that comment later. Let's because we don't support comments yet, we said we get likes line token column. Yeah. So if the column is here, let's go with LT territory. I'll be writing it a lot. Next. You're matching here. Yeah, I think that's the best way to go through it. It's just to have that match for the first character, and then that tells us what type of line we are in. Of course, that doesn't tell us much if it's a branch or not. It'll be cryptic, it's okay. Let's first let's see if this works or if I get an error. It's not mutable, of course. Okay, it's working. Because here I'm not actually declaring a variable. So maybe it's if matches. Probably better way to just do that, like with the interrogation point or something. But let's keep it matching here like so. If not, well, the tokens will get a new fella. Token type state. Let's state called state name. There we go. You know that. But it doesn't. Expanded string found a reference to a string. Let's just clone that fella. Or we can just move it. No, wait. Let's clone it. So now we're not at the point of performance. We need to sweat every single string on the lexer. So that work. Excellent. Okay. Cargo test. Okay. Perfect. Working as expected, I see. Content called argument looks like this. Okay. That's state name. Yeah, well, it's not. Of course, this here is. And I don't see that one here anymore. The state name does work. We managed to pass the state name. That's already quite nice. Now, the next one's gonna be, let's get those keywords out of the way early. That way right, yeah, we get those. Yeah, get those comments, not yet. And let's, maybe we do want to get a comment. We want to get a new, because Word, that way we can ensure, in Word, we don't get spaces, we don't get weird characters, we get the long word. That one can have more. So, and therefore, if we get this, we can assume we get if it's just a long word, the long word. Yes, we put it through here. Don't forget when we implement that. I need the look ahead before. So, oh wait, actually I don't. I just put it here and say it's a sum. I'm sending in the comment start, but we get it in long word mode. If we're long word mode, we just current word push, and then we continue. That way, in long word mode, we stop adding words, we just continue here, and then at the end, current word, if it's not empty, we check if we're in long word mode. But I'm gonna copy that line twice, even though I could make it in a. So that way, it's also not mistaken if we're at the end of the line and we get one of these, we have it down. Well, if there's no long word, that means it's an empty string. So let's the comment, let it be the result of the top next. Wait. Oh, that's unwrap or default. I don't care if I get one or not. I just care if I can. I just care that I have something in my comment here, and then I make sure. That we don't get anything else. This one's actually like, that means we are sending in some weird stuff. Like that means the Lexa itself. But it's not the to do. That's a panic. But maybe we don't care. Whatever. Programmed it now. And now we're gonna push a token. layers. What do you mean? Oh, it's not implemented for legs line token. What we assume. Oh yeah, well, we don't know if it's a long word yet, so I can't do that because that needs a reference. something else. Panicking. That's the base course of action. It doesn't have a long word. This is previous errors. Let's build option next. Previous errors. Need to clone the comment afterwards if we do it here. Superb. And we are on the tests. Outline, document. There we go. He sent a document. Oh yeah. We do need to trim that fellow. Or we don't get yeah, I don't think string does it. Actually, one passed. Yeah, we passed one more. There's one more. We still don't find the documents. We don't find the other keywords, but we got closer. We now can handle comments. It's nice. Was a bit silent for doing that. I guess that's the tiredness. See, there's nobody there. Let's get some extra ones. I need to be done sometime. Probably today, soonish. That's been how much time? 7 hours. Not without a real break. Yeah, that's kind of how my day goes in general. Hmm. What's the final? we match on the first token, and now we get the actual big boy token. It's gonna be the word. But when we get a word, we actually match first to see if it's a word like as STL. Because if it's else, we're pushing the token right of else. If it's an endif, and the rest, that's where the fun happens. So if I read it here, 23 passed. As you can see now, I got the else and endif that are recognized as well. Now it's function all the time. Therefore, second token, because we got the first token, of course, and now we're gonna match on the second token, because if the second token is an open parenthesis, that means we're getting a function call. So that's why we want to keep, by the way, all of this is why we want to keep this kind of stuff in this one file. That way I don't have to look at it too often. Because compiler work is the type of stuff you do, well, not at the end of the day after you've done all of the rest, because you're doing the bad decisions, the mistakes, and we need to. And that's why we don't want to. We want to keep all of that code that's complicated separate, so I can keep myself on the happy path in Castagne and not in the I've got to fix the compiler path. Most people don't want to be here. It's fun from time to time, but not every day, as we call it. So let that second token be it's the next one. If we don't have our second token, we will handle an error gracefully. Now we match that second token. If that second token is an empty if that second token is the empty yeah, if it's a parenthesis open, that's good. We are going through yeah, let me try. just in case. Check that we don't have anything else at the line. Well, that we already munched all the tokens. Because at the moment, the word can be quite complex, you know. You got the range indicator. Probably won't keep. We will break all of your Castagne scripts if I remove the. How do you call that? Actually, what do you call that in French? We call it the tier 6. But this character here, because it might be used for operations and for the ranges, and instead of just slapping it on and parsing it at runtime. But yeah, if its parenthesis is open, okay, in a function call, so therefore, if we have magic token type is function call for that word. Yeah. Because I want it to be the last character. Okay, so I don't have any argument list for now, but I'm getting there to a bit, and I'm matching that second token, and if it's not, I'm gonna. Because for the branches, that's gonna be tricky. Let's call it like let's call it like it is actually. It's gonna be tricky. Uh, yeah, because because a branch. Actually, a branch that's just a word and a column. Because I'm not actually splitting anything inside of it. I'm not using the comments. I'm not using the column or the parenthesis inside that. Yeah, I'm not having expressions. Oh wait, I'm using the comma though. I'm using the comma. So there's my Alexa is a bit wrong. It can't handle the branches in its current state. But also I need to have the branch because they're quite complex, especially with the frame and stuff. But at this point we don't really mind because in any case we will always get our cool tokens at the end, and that's what we need with the token type, because we don't need to care what branch it is at the moment, just branch type. We don't even need to handle branches, so for now we can wait. I'm putting here because that's gonna become very quickly an issue, except if we add a space. That kind of breaks all Castagne scripts if I do that. So I can do it. Like, I can annoy everyone and do that, but do I want to? That would make a lot of it simpler and a bit more robust because the search function always has some issues with that because of the way branches are written. Yeah, actually, you know, like if I do it a bit like this, like if instead of having F5, it's F2.5 2 point, maybe that can work. If I put space, that also can work. That's gonna annoy everybody, of course, if I do that. But do I want to do that? That's gonna be a question for another time because I'm starting to get a bit tired. Let's see if we can get the function call with no arguments to work out. It's an option already. Oh yeah. So I'm pushing the word .clone. Well, it's already trimmed, I guess. Oh yeah. 5. It's not if, it's let. Les previous errors. 74. Yep. It doesn't work here. Less. Oh. Less stuff works. Why the stuff that used to work? Expected end of line. Oh yeah, that's exactly the opposite of what I tried to write. Okay. 24 past. Not yet implemented, not yet implemented. Okay, yeah. Of course, we got that. Well, let's add the peak. Can we peak with an iterator in Rust? And after that, we'll be done for today. That's because I'm gonna have to take a bit of a break and go drink with my friends. Otherwise, you know, that's what we lock in peakable. What does that? Okay, so it's a peakable iterator. Okay, I see. My test still pass. Therefore, now I can actually handle this. It's a common start, but No, but I need. Oh yeah, this is not the one I want to actually pick. I want to pick with my Charles iterator. Yeah, one more. We can combine an iflet and an if. So therefore we're gonna have slight duplication, but we not really mind. We don't really mind that. In this case, it's simple enough. Oh, sure, reference. Like, what's the typo? What's the point? So, I'm getting it's a reference. It says yeah. So this is a reference combined with the sharp. It's like, and if I do that, I'm actually moving the value. If it exists, ah, okay. Oh, it's oh. Does that work? Still, still documenting. Oh yeah. Okay. In this case, I need to do kind of thing. I could have seen that earlier. I pull this with us. 25 past. Yes. Yes, we got it first. Let's document in a bit. That's code is a lot better that way. Yeah. We don't need that comment anymore. We need to. Whatever. Let's clean up our act. Now we got some. We got a lot of warnings. Let's see. Memory never constructed. Don't care. BSMate don't care. Yeah. Constructed never used. You're not actually getting any actual warnings that matter. Irrefutable patterns, that's for later, as we said. Variable does not need to be mutable. Yeah, indeed. 33. And use the import. Yeah, well. Let's actually clean these up when we stop having all of our dead code, all of our dead code not constructed. Actually, that's still gonna happen until we get there. Let's finish this up by doing a wrap up, and then we'll be gone for today. It's been a full work day, no breaks, no stopping. So today, what did we do? We did. We got that memory stack. The memory stack no, actually I think it was working yesterday, so that was not today. But we were at the end of the day I got like goldfish memory. What's the test? That's how we can check the test list. I think we get that. No, I think we did get that memory stack working. We did get the cask commands working, especially like the add, sub, mul, div, mod, min, max. That's good. We got the state handles. We spent quite a while. I did that. But yeah, what did we do? We did encapsulate this as an engine with entities, and we got that a basic engine tick. We got CASP functions to register, and we got, what else did we get? We got Ledex. It's in progress, but we got that Lexa starting to work. So next up, that way with that, it's you're gonna continue the Lexa. It's gonna handle functions with arguments. No need for branches yet, although that's something we're gonna have add very soon because we like having stuff that works. What we do after that is we get ourselves a nice the next compile step, which is that intermediate representation, which we'll find a cool name for. But they're basically like we check if functions exist. We're gonna need variables very soon, actually. Now that I think of it, because yeah, we're gonna need to. Otherwise, we can't actually get the results of a function. Well, not every function. We don't need add specifically. We could get a log function, but that would require closure. So that's gonna be an or question. Probably, but yeah, let's we're gonna have to add variables to this thing. Otherwise, we don't get jack. Then we'll also, and after that, we'll add the we compile to cask plus metadata. So there's gonna be a tuple cask and that metadata that brings back to that intermediate representation. And then we do the optimize step. Just the skeleton, not the active thing. And then we can test the full run. Because we test the full run from a cast file, and then we're gonna add a command line argument to the binary. To check a CASP file for errors. Why do we want to do that? Because first of all, it's cool. The second of all, that's gonna stop our dead code warnings. Because that's kind of the thing here is that I mean, until we get to the coded bindings, the engine actually never runs. So that's kind of just a library. And while I guess it's cool, it's not what we expected yet. So while yeah, the functions are public, but some are never called, some are never that will also allow that to happen. Very simple crate, of course. But yeah, this is where we will leave. I'm gonna save it so I can get it to the next time we're here. So that way we do have we can open it back again. Where we left off. But yeah, that's gonna be another long day of work. If we be honest, like connecting with Alexa, we do that internet representation. Once we get all of that done, once we manage to go through all of that here, now we will be able to add the modules. Which means that's where we're actually starting to build the actual Castagne functionality. Or expand on what we have. So the branches, strings, all of that, gonna gonna see what we go through first, but maybe this one's a bit more smart. But yeah, of course. But yeah, anyway, it's been various levels of fun today. I hope you enjoyed it since you guys have requested it. I don't know if that's what you expected, but yeah, we'll do what we can here. Will I make another one tomorrow? Maybe yes, maybe not. Well, I'll see what it goes. But if that's something that people are interested in, I will be programming anyways. But yeah, see you next time, guys, and have a nice day or night.